Hi guys, this is Leela. Welcome to my channel leelawebdev. So in this video we will learn about the another new concept in Angular 18, that is signals. So what is this signals? So now let's try to understand the signals. Signals in Angular are a way to manage state and reactive data flows similar to how observables or behavior subject are used in RxJS. So that means here signals means it is the way to manage the state and reactive data flows, it seems. So similarly how observables and behavior subject we have used in RxJS, in the same way signals are also useful to manage the state and the reactive data. Okay, so we understood about this signal definition. However, signals are more lightweight and built directly into Angular's reactive system. So then if you have already the observables or behavior subject, then what is the use of these signals? Then you may be having a doubt. So here I am giving you the explanation for that one, that however signals are more lightweight and built directly into Angular reactive system. So that means these are directly built in the Angular reactive system, whereas the RxJS means we need to install a separate package library on the top of the Angular. So now let's try to understand the detailed breakdown with explanation and examples. So first of all, what is a signal? Okay, what are signals? So let's try to understand what are signals. So let me paste here the data. So what are signals? A signal is essentially a wrapper around a value that notifies consumers. That means consumers means functions, components or services. So whatever it may be, whenever the value changes. So that means signal means it is telling that it is a value or value will be there. It will, the signal will act as a wrapper to that value, and whenever that value changes, this signal will notify to the function, component, services, whoever is using that value. That is the signal. This allows for a reactive data flow. So that means whenever the value changes, if it is notifying means, then it is nothing but reactive data flow, where changes in the signal's value can trigger updates elsewhere in the application. So that is the thing. So let's understand the characteristics of a signal. So what are the characteristics of a signal? So characteristics of a signal, I will try to go, yeah. So now what type of value that the signal will hold? They can hold any type of value, like primitives like number or strings, or more complex structures like objects or arrays. Signals expose a getter function for reading their current value. So that means signal will have a getter function in order to read the current value. Signals notify Angular when their value is used, allowing Angular to track dependencies automatically. This is useful for creating reactive application. This is one. These are the three things. So now you need to understand another one is types of signals. How many types of signals are there? So we also have a types of signals. There are two primary types of signals in Angular. The first one is writable signals, which we will try to learn it now. Writable signals. These can be updated by the developer, meaning you can both read and modify their values. So that means we can update it, and also you can both read and modify the values. And next one is the read-only signals, which we will try to learn it afterwards. These only allow reading the value, but you cannot modify it directly. That is one thing. So now example of a writable signal. So now let's try to learn about the writable signal. What is the example of this one? So now creating a writable signal. So how can we create a writable signal? So you can create a writable signal by calling the signal function with an initial value. So how it will look like? So let's try to show you our example. So here constant count is equal to signal of 0. So we are creating a signal with initial value of 0, and we are consoling.log count, and we need to use the brackets like this. So here the count function is a getter function. So here you need to understand that the count function is a getter function for the signal value. By calling count like that, you will access its current value. So now updating the current signal. So updating the current signal. So how you can update a writable signal? So you can change the value of a writable signal using two main approaches. One is dot set and also dot update. So using dot set, the dot set method allows you to directly set a new value for the signal. So how can I set the value? So here I will try to show you the example. Count of set 3. So it will update the signal value to 3. So whenever you try to print the count value with a getter function, then it will print the 3. Why? Because we have updated the value with a 3. So now in this case, so what I want to tell you is, in this case the count signals value is changed to 3, and any consumers, here consumer means the component, services or functions, anything of the signal will be notified of this update. That is one thing. The second one which you need to understand is the using dot update. So here using dot update. The dot update method is useful for situations where you want to modify the current value based on its previous value. So I will try to show you this one. So constant dot update of value plus 1 increments the value by 1. Console.log of count. So here I want to explain you the clear example for this one. So here the update method receives the current value as an argument, here value in this case, and it returns a new value that is then set to the signal. This is great for more complex updates. So I want to explain you with a simple example by creating the simple counter component. We'll try to do it. So let me open the project here and I will create a component, counter component. Let us create it and we'll try to create a simple counter increment and decrement thing using this counter component so that we can able to see the output for this one. So we have created a counter component. Let's open this counter component, counter.component.ts file and counter.component.html file. So like this, and here also app.component.html file. So here I will try to update it within app-counter. That's it. So now if you try to see here, it will get it. Yeah, let's save it. And here we need to create a counter. Okay, let's try to create a counter. Count is equal to signal of 0. So we need to apply signal of 0. So this is the default value which I am trying to do, initializing the signal with a value of 0. And the next one is, so we will have two methods, that is nothing but increment and decrement. Increment, and here I will try to do this dot count dot update, and you will get the current value, and I will update it with like this, and we will be having a decrement, and we will be having a count value, this dot count dot update, and the value will be value minus 1. That's it. So now this is the signal how we can do it. This is a simple signal, and here you can have something like counter example. Okay, so here I can write something like counter, and here we need to call it something like count like a method. Okay, and here I will be having div, and I can have a button, and here I can write the increment, and this one will take something like click is equal to increment. That's it. And in the same scenario we can have a decrement, and here also we can have it like this. Now if you try to see the output for this one, if I update the value, it will get update, and if I am decreasing the value, it is decreasing. So that means, so here we are using the concept of signals, and we are able to achieve the reactivity for this one. So this is what I want to tell you. So this is all about the signals. So let's try to give me an explanation to this one. So in the template, if you try to see the template property, so the signal's current value is read by calling the count function, by getter function. This allows Angular to track the signal's value and automatically update the view whenever the signal changes. And we are having the update the signal. The button triggers the increment and decrement methods, which call the dot update on the count of signal. So here on the count signal to modify its value. The update method ensures that the value is incremented or decremented, and Angular will automatically update the displayed count in the UI. So that is one thing. And what is the benefit of using these signals? So let's try to understand the benefit of using signals. So now we are able to achieve this one, right? So we need to understand the benefit of using signals. So here the benefit of using signals is 3 points I want to tell you. Simple state management. Signals provide an easy and direct way to manage state in the Angular application without having to deal with observables or subscriptions. Reactive. Since Angular tracks where signals are used, any changes to a signal will automatically propagate to components, services, or any other consumers. Type safety. Signals are typed, making them predictable and safer to use in TypeScript heavy applications. That is one thing. And the key points which you need to remember while using the signals is, so let's try to write about the key points also. So the first one is, signals allow for efficient and automatic updates whenever value changes, making them ideal for reactive use. Writable signals give you control to both read and update the state using .set or update method. And Angular tracks signal usage, meaning that you don't need to manually manage subscriptions, unlike when using the RxJS observables. So in conclusion, so what I want you to tell you is, signals in Angular provide a streamlined, I want to tell you here. Yeah. Signals in Angular provide a streamlined reactive way to manage and update state. They simplify handling state managements and eliminate much of the boilerplate code traditionally associated with observables and subscriptions. With the ability to track dependencies automatically, signals improve the efficiency and responsiveness of the Angular application. So this is all about the basic introduction to the signals concept, and also we have did a simple example writable signal also. In the next video, we will try to learn about the readable signal also. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will try to learn about the another type of signal, that is nothing but read-only signal, which is called as a computed signal. So let's try to learn about this one, computed signal. So I will try to write it here so that people can be able to understand. So we are learning about the computed signals. So now, computed signals in Angular are a powerful way to derive values from other signals and track dependencies between them. So let us break down the concept of computed signals, including their lazy evaluation and memorization with detailed examples. So here I am trying to tell, what I am trying to tell is computed signals in Angular are powerful way to derive values from other signals. So that means it will derive the values from other signals, computed signals. So let's try to see. So what is this actual computed signals? Let's try to understand it. Computed signals are read-only signals that derive their values based on other signals. I told you, right? Unlike writable signals, computed signals cannot directly modified. They are computed by a function that uses other signals as an input. So how do we define a computed signal? So defining a computed signal, so how we can define it? To create a computed signal, you must use the computed function and pass a derivation function like this. So here is a simple example. So what I want to do is, so here I would try to show you a simple example. So constant count of writable signal is equal to signal of 0. So this one is normal signal, and double count is a computed signal. So here we need to have a computed method, and in this one you will be having a callback function or derivation function, so which it will return the value. So in this example, count is a writable signal, meaning its value can be changed. Double count is a computed signal that derives its value from count. It is always equals to count into 2. Okay. So now let's try to understand. So whenever the count signal changes, so you need to understand this one. So whenever the count signal changes, Angular automatically knows that the double count signal needs to be updated because it depends on the count. Angular will trigger revaluation of the double count the next time you access its value. I will try to show you a basic example for this one. So here I am having the code. Okay. So let's close this one. And here I will be creating a new component, ngGC computed signal. Let it create. So here the the count has been created. So I will try to show you the example for this one. So now let's go on to this computed signal, computed signal.component, and here also you have computed signal.html. Okay, so these are the things, and here app.component.html. Sorry, and here I will use app-computed signal. Okay, and automatically the output also will change. So now let's try to create a first count. Okay, count is equal to signal of 0. So this one is a writable signal, and if you hover here, you will be able to see this is of type writable signal of number. So if you want, you can mention the type also. So here you can write writable signal of number. What is the value it holds? The number. Now if you want to define a computed signal, means then what I need to do here? So here I need to use double count. Okay, double count, it is of type signal of number, and this one also holds the number. Double count of number is equal to computed. Okay, or otherwise if you mention this one as signal of 2, okay, then you will get the signal as a signal number. So but here what you need to mention, it is a read only, then you need to mention it as a computed of, and here you will mention this one as count. Okay, count, and this should be this dot count into 2. That's it. So this one is our computed signal. Now how can I check the output for this one? ng on init. So just I will try to ng on init, and here what I will do, I will try to console.log of double count, console.log of double count. Okay, now if you try to see the output for this one, so here I am able to see the 0. Why? Because right now the count value is 0, 0 into 2 is 0. So now what I will try to do, I will try to update the count value. So count dot set, this dot count dot set of 5. Let's say that I will insert it as a 5. So now the same double count, if I try to output it, let's see what could be the output for this one. So now if you try to see here, so this time the value was 10. So that means in this example what I am trying to do, initially double count is 0 because the count is 0. When the count is set to 5 is called, double count becomes 10, 5 into 2. So this is what about the computed signal. So next concept what I want to tell you is the lazy evaluation. What is this lazy evaluation? So same in this one only I want to explain you about the lazy evaluation. Computed signals are lazily evaluated. This means that Angular does not compute their values until you actually read them. If you never use the double count signal in your code, its derivation function is never be executed. So what is the meaning of this one? So let me try to explain it to you. So let's say that I am having another computed signal, that is nothing but expensive computation. Let's say that I am having, and I will use the computed of, and here I will try to do console.log. So I will use expensive count running, something like this, so that we can able to see that whether the code is getting executed or not. And here also what I will try to do, I will return count into 100. That's it. So now this is our this dot. So this is our expensive computation. Now how we can call this one? So now how it will be called? For example, let's say that when I am trying to execute here, it is not calling this one will not be called. For example, let's say that I am having a button. Okay, button expensive count or something like this, and here I will use a click method, click expensive count, something like this method I will use it. Okay, and now if I try to go here and if I try to mention it this one, and in this one what I will try to do, this dot expensive computation. So I will try to console.log this one. So here I will try to do the console.log of like this. So that means, so whenever you call this expensive computation, then only this logic will be executed. Other than that, before at the starting of this one, this computed method will not be executed. So in this case, the derivation function for expensive computation only runs when the value is read for the first time. So here when it will be reading for the first time, when you click on this button, so then only this console is coming. See, so now only then only it is executing. So this is what about the laziness. So that means it will not be calculated at the starting phase. So whenever the value is read for the first time, then only it will be calculated. The second one is the memoization. So what is this memoization? I will try to explain you before showing you the example for this one. So now if you try to go here, it's a memoization. So computed signals are also memoized, which means that they cache their calculated value. Once the value is computed, Angular will store it. If you read the value again without any changes to the dependencies, count in our case, Angular returns the cached value instead of recomputing it. For example, let's say that you are having here the button, right? When I am trying to click on the button, so it is executing this one. So now I am not changing the count value. So it is initially the count value is like that only 5. Okay. So now when I click on this one at the first time, so you will be able to see the console is being fired. So that means the logic has been executed. So now when I click on again on this button, so this logic will be executed again? No, it will not be executed. See, this output has not been came, only one time only, at the starting time only it has been came. The next time the console is not printed. That means the logic what it is mentioned in the computer, it is not getting executed. So that means until and unless you haven't changed the count value, the value will be, the return value will be cached, and always that cached value only will be returned. So now there is no need for us to execute this value. So that is one thing which I want to explain you. And also another one which I want to explain you is, for example, let's say that when this one will be executed. So let's say that I am having here another one, increment. Okay. increment, and here also I will use increment. So now if I try to use this increment here, and now here in this one I will try to update the value. This dot count dot update of value is equal to value plus 1. So now now the value has been, so now when I try to click on the first time, the count value is 5, you know that, and if you click here, the execution has been done. Why? Because the count has been fun. So now it is lazily loaded, so that's why it has executed the file. Now when I click on the expense account, all the time you are able to get only the cached value. Now this time I have incremented the count value from 5 to 6. Now if I click on the expense account, will it return the cached value or will it count it again? So now here you will be able to see expense account. If I click here again, so now you will be able to see again the console.log has been executed. That means it is able to check that the count value has been, the dependency which is there, the count value has been updated. So that is the reason I need to recount it again. So now it will not return the cache value. So that is the main thing. Since computer signals are memorized and lazily evaluated, you can safely perform computationally expensive derivations in them. For instance, you might have a signal that filters a large array based on a condition. So I will try to explain you this one. For example, let's say that I am having a like this. Okay. So items, writable signal of number, something like this I am having it. Okay. So signal of 1, 2, 3, 4, 5, 6. Now what I want to do here, I want to calculate the computed thing. So here I will try to write an even number. So here I will try to write the even number. So here this dot and here, yeah. So now this is our even item. So that means here I am having an items and I want to filter out the even numbers from this one. So I have written the condition like this. Now whenever I try to call the even items, so here when I click on the expense account, so here I will try to call this even items. Okay. So now if I try to refresh this page, when I click on this one, see here you will be able to see filtering even numbers. So the count has been done. Now when I click on this one, only the output is coming, cached output is coming. So that means it is not executing the filtering even numbers logic again and again. So here what happens in the above example, the computed signal even items only filters the array the first time you read it. On subsequent reads, the cached result will be written. So when the item signal is updated, for example, let's say that, so I have updated the item signal. So in such a way that items is updated. So here in the increment, let's say that I have updated the items. Let's assume. Okay. So now when I click on all the time, so when I click on all the time, so you are able to get only the cached value where I have incremented. So that means the count values has been updated. So updated means it has been modified. So now when the items is updated, the cache is evaluated, and the next time you read the even items, it performs the filtering operation. See. So this is how it will be happen. So now you need to understand that when to use this computed signal. So this is also one of the important thing. So now here when to use the computed signal. I want to explain you each one by one. So data transformation. Okay, use computed signals when you need to transfer or compute data based on other signals. So another one is, which is the extensive operations. If the derivation function is expensive, example sorting or filtering large data sets, computer signals are ideal because they ensure that the computation only happens when necessary and the result is cached. Read-only data. Since computed signals are read-only, they are perfect for data that should not be directly modified by the components or services, but rather derived from other sources. So this is what about the computed signal. In conclusion, what I want to tell you is, before closing of this video, computed signals in Angular provide a reactive, efficient way to derive data based on other signals. Their lazy evaluation and memorization ensures that computations are performed only when needed and avoid unnecessary recalculations. This makes them ideal for scenarios where performance is critical, such as filtering or transforming large datasets or performing the extensive computations. So this is what about the computed signals. Still a lot more is there to learn about the computed signals. We'll try to learn it in the next video. Hope you understood about these basics of the computed signal. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel leelawebdev. So we are learning about the computed signals. So I want to tell you that computed signals are not writable signals. So that means, so these are just read-only. Computed signals derive their values from other signals, I have already told you, and cannot be directly modified. If you try to assign a value to a computed signal like a writable signal, it results in a compilation error Actually it will not allow us to write that code also. I will try to show you some simple example for that one. So here I will remove this one all, okay, and here I will remove this entire code also, okay. So this is our count, which is a writable signal, and this is our double count, which is a computed signal, that is nothing but read only signal. So if I try to change it, so now here ng on init, okay, ng on init. In this one, so if I want to set this dot count dot set of, so I will try to set it as 3, and here I will do console.log of this dot double count, I will try to check the output for this one. So if you try to check the output for this one, see output will be, oh sorry, it should be something like wrapper, right? Yeah. So the output will be always, it is a 6. So fine. So that means it is allowing us to change the count value. So that's why the double count also got updated. But if I try to change the double count value, so here I will try to change the double count value, double count dot set. Now it will result to an error, and also here also it will result to an compilation error. So here you will be able to see the compilation error at the bottom. You will be able to see here. So property set does not exist for the type of signal. Why? Because it is a readable signal. Property set does not exist on the type signal. So that means computed signals are not writable signals. Here double count is a computed signal that calculates twice the value of the count. Since it is derived from the count, trying to directly modify the double count is not allowed. And the another one which I want to tell you is the computed signal dependencies are dynamic. This is also one concept which you need to understand. So dynamic means Angler tracks the dependencies of a computed signal only when they are accessed. So only when they are accessed only the computed signals can able to find its derives. Dependencies are added or removed based on the values being accessed during each execution. So now I will try to show you one concept. So here I will be having a show count. Let's assume I am having a show count. Okay, show count is equal to, it's a signal of the value is false. That's it. So now on ng or init, okay, so I will have a conditional count, conditional count is equal to, so this is the conditional count which I want to explain it to you. Conditional count, right? I am explaining conditional count. Conditional count is, it's a computed value, computed of, now it is dependent on two values. So now for example, if not of this dot show count, if it is not of this dot show count, I will do console.log of nothing to show here, or otherwise what I will try to do, I will try to return the value. Okay, return nothing to show here. I will do something like nothing to show here, and if it is else means, then I will try to do return the count value is dollar of this dot count, this dot count. That's it. So now if you try to observe this computed value, okay, so if you try to observe this computed value, it is dependent on the two values, two signals it is dependent. One is the show count and another one is the count. Now here if you try to observe carefully, so what I will try to do it is, so here if you try to observe carefully, I will have a button, okay, get conditional count value, okay, conditional count value, and here I will try to do click is equal to get condition or something like this, whatever the thing. So I want to demonstrate to you. So I have a method, and here I will try to calculate, I will try to do the console.log of this dot conditional count. That's it. Okay, so I want to get the value for this one. So now if I try to update this value, what will happen? So now here if I try to update get condition, okay, this one is not a button, oh sorry, so I will try to add it as a button. Yeah, now this one is a button. If I try to click on this one, so you will be able to see the count value is 0. So why it is getting the count value is 0? Writable signal if not of this dot show count. Okay, so here it should be something like this. Yeah, so now if I try to check the output for this one, if I click here, so we are able to get nothing to show here. Why? Because the show count value is false. So that's why if it is false means nothing to show here is there. So that means it is now we know that the conditional count is dependent on two values, that is nothing but show count and the count. Now I want to update this count value also, whether it will fire or not. So if you try to get the value count, okay, count value, sorry, increment, and also here also I will try to do the increment. Okay. Now let's try to observe the value for this one. So here I will do the conditional count value also. Here I will try to show the conditional count value. So here I want to show the value of this conditional count. Now it will be clear for you. So here let's go to the increment. So what I want to do it is this dot this dot count, this dot count dot update of value is equal to value plus 1. Okay, so this is the thing which I want. So whenever I am trying to increment this value, if you try to observe here, so I will try to do the console.log also here, console.log executing the computed. Okay, so now we know that the conditional count is dependent on this one, right? So whenever I am trying to execute here increment, okay, when I am trying to increment here, so it is not getting executed. So this conditional count is not even though we are mentioning it in the template. If I try to execute here also, so even though I am mentioning it in the template, so this console.log is not getting. So that means we know that this computed value is dependent on the two values, that is nothing but show count and count. Whenever the value is getting updated, either show count value update or count value update, it needs to re-execute this computed value, but it is not getting executed. So what is the reason is, so here at the time of execution it came to across is false and it has written this one and stopped the execution. That means the dependencies are dynamic, so dynamically able to understand that show count, it is dependent on only the show count. Now when I try to change the computed value, show count value for this one, so if I try to change the show count value for this one, so update show count, if I try to change the update show count value, if I try to update this one, so let's try to have this update show count, then you can able to understand it. So here if I try to do this dot count, sorry, show count dot update of value is equal to not of value, so opposite side I am updating it here. So fine. So now if I try to see here, if I always clicking on the increment, we are not able to get the output, and also here the computer value is also not executing. Now if I click on the update show count, immediately executed, the computer has been executed. Now when I am trying to execute here, see, executed the computer. So that means all the time the computed value is executing. So that means, so here you need to understand that, so here again it is not incrementing. So here you need to understand that the dependencies of these are dynamic. Initially when the show count is false, the computed signal conditional count only access through show count, returning the nothing to show here at this point. Count is not a dependency. If you change count, it won't trigger a recomputation of the conditional count, because count was never accessed when show count was false. So that is the concept I want to tell you. So that means computed signal dependencies are dynamic. The next one which I want to tell you is that dependencies are dynamically added or removed based on what get accessed on the computer. In this case, once show count becomes true, count becomes a dependency, and any future updates to count will trigger recomputation of conditional count. So that is a common thing. The next one which I want to tell you is the reading signals in the on push component. So all the people, you may be getting doubt that what about the change detection strategy? If the change detection strategy on push is there, means will the signals work? So in on push components also, Angular optimizes change detection by limiting the rechecks. However, when signals are used in on push component, Angular tracks them as dependencies, ensuring that the component is updated when the signal changes. So that means if I try to change it here to change detection strategy dot on push, sorry, not default, on push also, then also it will work without any problem. So here if I try to increment here, we are not able to get conditional value here, so we are not able to get it. And now if I click on this one, so now the value is got updated. Now whenever I am incrementing, the value is getting updated, the template is getting updated. So don't think that only the input and the event values on only these changes will be done. So here it will be done. So that is all about the concept which I want to tell you. So summary of the key points is, so computer signals cannot be directly modified. They derive their values from other signals and don't accept direct assignments. Computer signals only track the signals accessed during this evaluation. Dependencies can be added or removed based on the current logic. Signals on the on-push components. Angular automatically tracks signals as dependencies when they are accessed in templates of on-push components, ensuring that signal-based changes trigger updates. These features help Angular efficiently track and update the UI based on the changes to signals without unnecessary computations. Hope you understood about this computer signal concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will try to learn about another important concept, that is nothing but effects. So what is this effects? Effects allow you to trigger side effects when one or more signal value changes. So if you want to execute any side effect or any logic, if you want to execute whenever any one or more signal value changes means, then we will be using the effects. And they serve as an important tool for integrating signals into different parts of an application. So let's try to understand a detailed breakdown of each section with examples. First of all, let us try to understand what is an effect. Okay, so that is the thing. This is the main thing. An effect is a function. So it's nothing but a function that runs whenever a signal changes. Signals in Angular are reactive variables that notify consumers. Here consumer means component, services or anything, when their values are updated. When you create an effect using the effect function, Angular tracks the signals used within that effect and reruns the function when any of those signals changes. So that is one thing. So what is the syntax for this one? So I will try to explain you here. So this is the syntax for this one. So constant count is equal to signal of 0, and here we will be using effect, and here we will be having a function. In that function I am trying to use the console.log. So in this example, if you try to observe, count is a signal with an initial value of 0, and the effect function is used to log the current value of count. Every time the value of count changes, the count value changes, the effect will run again logging the new value. So that is the syntax of this one. How effect works? So first one is how effect works. So how does this works? First one is initial execution. So at the initial time of the execution, what it will try to do? Effects always run at least once when they are created. Okay, so that means at least once when they are created, immediately it will run. This means that the above effect will immediately log the count even if the count has not yet changed. The first time execution will be there. Next one is the tracking dependencies. So the next one is tracking the dependencies. When effect runs, it tracks the signals it interacts with. In this case, it tracks count. If the value of count changes, Angular knows to run the effect again. Next one is asynchronous execution. So this is also important. Effects execute asynchronously during Angular change detection process. This means the effect will be re-executed after Angular finishes processing changes in the application state also. So that is one thing which I want to explain you. So let's try to have a simple example for this one. So now I will try to do it. So here let's say that here what I will try to do is I will increase the settings. Okay, so 24 I will increase it. Fine. And let's go to the computed signal, and here also we will be having the same computed signal, right? So let's try to remove this all HTML and all those things. Sorry, here I will try to remove this one all, and here also I will try to remove this entire code. Okay, so this one is it's completely different. So first one, how we can define this one is ng on init, or otherwise we can take it as count is equal to signal of 0. So this is one thing, and we need to use the effect, right? So let's say that first of all we have an increment function, increment. Let's assume that we have an increment method. So in this one, what I will try to do, this dot count dot set of, sorry, this dot count dot set of, or otherwise we'll try to do it as an update. Okay, what is the problem here we are getting? Yeah, nothing. Okay, we should not have the function. Yeah, this dot count dot update of value is equal to value plus 1. So we have updated the value increment, and we'll be having an effect. Let's try to use the effect. Okay, sorry. effect, and this should be here. I will be using it like this, and here effect means here you can use effect. Okay, so the effect console.log, here I will write console.log the current value is dollar of this dot count. That's it. Okay, now I will try to do like this. Yeah, so now we have executed the effect. What is the wrong in this one? No. So here in this ng or init, I have used the effect. Now if you try to check this one in the console, so what is happening here? Oh sorry, we should use the effect only in the constructor it seems. Okay, so let's try to use this one in the constructor. Okay, so now let's see whether we can able to see the output or not. So now here we are able to see the current count is 0. So now when I try to update this increment thing, so now for example let's say that here I will be having a button, okay, increment, sorry, and in this button what I will try to do, on click I will be using the increment. So this is the method. Now let's say that, now let's see that, so now whether this effect will execute or not. At the starting of the time, initial execution, the current count is executed. Whenever I am trying to increment it, so here you will be able to see that effect is also getting executed. So here what I am trying to do in this example, increment, whenever the increment increases the value of the count, triggering the effect to log the updated value. So now use cases for the effect. So you need to understand the use cases for the effect. I will try to explain you. Although effects are rarely needed in most of the application code, they are valuable for side effect heavy operations where reactive signals interact with non-Angular systems such as logging, browser APIs or custom rendering. So let's say that for example, so you are having a user action, okay? So you are having a user action of, so what I want to tell you is, so let's say that here I don't want to execute the code, so just I want to show you the scenario. So we are having a user action of something like this, and here I will be doing the effect something like this, okay, this dot user action, okay. So whenever I am trying to update this one, user action dot set of submitted, so ng on it, okay. So whenever I update this one, so now you need to have some side effect, user action change like this, you need to have a side effect, right? So this side effect will be executed, okay. And also syncing with the local storage. Suppose you want to save the current state of an application to the window.local storage means, then also you can use this one. So whenever you are trying to change the user value, automatically some action has to take place. That means storing in the local storage. So you can use the effect. And also the custom DOM behavior. So effects can be used for the DOM manipulation that can't be easily expressed in Angular templates. If you want to change some DOM manipulation or anything means, you can also use it for this one also. So let's say that custom rendering the custom elements also, like canvas or charting library, those things also you can use it for this one. So when not to use the side effects. So you have understood when to use the side effects and all those things. So when not to use the side effects. So when not to use the side effects is, avoid using the side effects for state propagation. That is, don't use effects to drive changes in one signal based on the other. This can lead to unwanted sequences like expression changed after it has been checked errors, infinite loops of re-triggered updates, unnecessary change detection cycles which hurt performance. For example, let's say that you are having some example like this. I will try to show you the example. Let's say that I am having a signal of 0 and I am having B signal of 0. And in the effect in the constructor, you are trying to set the A value. So this is a bad practice. This creates a circular update loop. Why? Because here this effect is dependent on the two values, that is nothing but A and B. So whenever the A updates, again the effect will be executed. Whenever the B updates, again the effect will be updated. So that means it is dependent on the two signal values, that is A and B. So in this scenario, in this case, if A, in this case what it will happen, if B changes, A will also be changed. But when A is updated, this effect will run again, potentially creating a loop or an expression changed error. So you should never try to do this one. So if you want to do this one, so I will try to show you. example for this one. So let's try to implement this one. So we are having two signals. So let's try to delete this constant variable. Okay. So now I want to update this one. So here I will update in such a way that in the constructor I will try to write the value for this one. Okay, this dot is equal to this dot, something like this. I am trying to do it. Okay, now if you try to see the output for this one, so maybe you will be getting an error. Writing to signals is not allowed in a computer or an effect by default. Use allow signals, writes this one. So now in this case, if B changes, A will also change. But when A is updated, the effect will run again, potentially creating a loop or an expression change error. If you absolutely require as necessary, you can enable signal updates inside effects by setting the allow signal writes flag when creating the effect. However, this should be done with caution as it can still lead to the above issues. So that means we need to use the allow signal writes to true. So here, whenever you are trying to write it, here you need to provide as the second one, that is nothing but allow signal writes to true. Okay. So this unlocks the ability to modify the signals within the effect, but it's generally better to refactor your code to avoid needing this feature. When to use the computer signals instead. So now you will be able to understand that when to use the computer signals. Okay. So when to use means if you want to model state that depends on the other state, use computer signals rather than the effects. Computer signals automatically derive values based on other signals and can propagate changes without risk of side effects. So we have already seen about that. So the total summary of this one is, so before closing of this video, so the summary of these effects is, which I want to tell is, effects are a powerful way to trigger operations based on signal changes, but they should be used more cautiously. Common use cases include login, DOM manipulation, syncing with browser APIs like local storage, and custom rendering with third-party libraries. Do not use effects for state propagation, that means the state updation, as this can cause performance errors or errors issues. Instead, rely on the computer signals for handling reactive state changes. So this is all about the effects thing. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will learn about the another important concept in the effects. That is nothing but understanding the injection context and also the effects in Angular signals. So now let's try to understand about this one. So normally, if you try to check it in Angular, signals allow for reactive data flow. So we know that signals are used for reactive data flow. With effects, you can respond to changes in the signal values, just like the computer signals and all those things. With effects, you can respond to changes. So that means you can execute some set of logic whenever the signal value changes. However, to create an effect, it needs to be done within an injection context. So that means if you want to create an effect, you cannot create it anywhere, wherever you want it in the code, you cannot create it. It needs to be done in the injection context. If you try to understand about this injection context, I have explained you about this injection context before only. So that injection, depending the dependency injection, where the dependency injection should be imported or injected, I have told you that should be done in injection context. So that means the effects also should be created in injection context only, where Angular's inject function can be accessed. Typically, this one will be done in the constructor and run in injection context. In the injection context, you will be having. So this is typically within a component, directive, or a service. So that means you can create an effect only in the component, directive, or a service where the injection context will be available. So the first one is creating effects in a component constructor. Let's try to see how we can create in the first place where we can create the effect is in the component constructor. When creating an effect inside a component, it monitors the changes to a signal and performs some action when the signal updates. The easiest way to register an effect is within the components constructor, because the component provides an injection context by default. You know about this one. So for example, let's say that, let's go to the example for this one. So I will try to go with a simple example. And here you will be having a signal component, okay, and let's say that I am having a count, okay, so I am having a count here. I will remove this entire code and I will remove this button also, and here I am having a simple signal. So now where can I define an effect? So if I try to write an effect here directly, okay, so you cannot able to write the effect here. So console.log of, so you can write the count value is something like this, you can write it, right? So I will try to import this one. So here I can write it. Now it is showing an error here. The effect which lacks the something it is showing. So that means we cannot create it here. So it should be created in a constructor where the injection context is available. Constructor, and here you can define an effect without any problem. The effect will be created. Now again the output is working. So here effect is used inside the constructor which locks the signal value to the console every time the count changes. The inject function used internally by the effect works here because the constructor provides the injection context. That's it. So now you can also assign an effect to a field also. So you can assign a effect to a field also. You can also assign the effect to a class field. This approach helps give the effect a descriptive name and can make the code easier to understand and manage. So whenever you are trying to give a name, so instead of this one in the constructor, if you want to provide it at the outside means, then what you need to do it is, here for this one you can give it to a class field name or a class property name. So let's say that a logging effect. So you can create it with a logging effect is equal to. So you can write it like this also. So that means this one is a class property name. You can also mention it like this. So this gives a meaning effect and also descriptive name, and also it will be easier to understand. The effect is now stored in the logging effect field, which makes the code cleaner. The functionality remains the same. It locks the count value whenever it changes. So then also it will change. Creating effects outside the constructor using injector. So now the second one which I want to tell you is creating the effects outside the. If you want to create an effect outside the container, how can you create it? If you need to create an effect outside the constructor, you can use Angular's injector to explicitly pass the injection context to the effect. This is helpful when you want to defer the effect's creation, perhaps based on external conditions or user action. For example, let's say that if you want to do it means, let's say you are having the increment method. Okay, so let's say that we are having an increment method. Whenever you are trying to do an increment, I need to call this effect. Okay, so I need to call this effect, let's say here, or otherwise let's say that initiate logging, initialize logging. Okay, so this is the method, and here logging, I will try to give you this one, and this is the method which we will try to use it, and here I will be using it here like this. So now you will be getting an error here in this one. So why? Because you will be getting an error, cannot find initial. Okay, logging effect, let's try to give me this one. Yeah, now right now you are not getting any error. When I try to click on this login, now you are getting an error in the console that it will tell same as it is. So whenever you are trying to inject, so it should in the injection context such as constructor, a factory function, a field initializer, or a function used with the running injection context. So that means we need to use the running injection context. So when I try to use the running injection context means what I need to do, I need to use a constructor. Okay, and here we need to inject the injector. We need to have the injector, that is nothing but injector. Okay, and here you can write something like run in injection context, and you need to provide the injector. Okay, and here you will be having a factory function, and that factory function in this one you will be doing it here. That's it. So now if you try to injector, okay, cannot find name injector means, so you need to Angular code. That's it. So now when you try to do it, and if I go to the console for this one, and if I try to check the console for this one, let's go to the console. Yeah, when I click on login, now this time you will be able to see the count is 0. So that means all the time the effect is executing. So instead of using this run in injection context, you can inject this one, and also you can use the effect like this. So like this you can use it, but here you can provide the injector here as the second argument. So here you can provide the injector, and here you need to provide the injector, this dot injector, sorry, this dot injector. That's it. So now if you try to see the output for this one, then also you will be able to see the same output. So like this you need to provide the injection context. Here initialize logging is a method that creates an effect when called instead of in the constructor. The injector is passed an option to the effect, ensuring that it has an access to the necessary injection context even outside the constructor. So the last one which I want to tell you is the destroying the effects. By default, Angular will automatically destroy the effects when the component, directory or service that contains them is destroyed. However, you can also manually destroy the effects by capturing the effect ref returned by the effect function. If you need effect to persist beyond the lifetime of its host component directory, you can set manual cleanup to true and manually destroy the effect. So how we can do this one? So let's say that you are having a logging effect. Okay. So I will be removing this one all. So let's say that you will be having a logging effect like this. Okay. So this one will be automatic. This logging effect will be automatically destroyed. Okay. If you try to understand clearly, this logging effect will be automatically destroyed when this component is destroyed. But if you want to manually manually do the cleanup and all those things, means then you need to provide an option that is nothing but in the effect manual cleanup to true. Okay, when you use this manual cleanup to true, then this effect will not be destroyed even the component has been deleted. Deleted means even if the component is destroyed, this effect will not be removed. So what you need to do, you need to write it in the manually destroyed means, so you need to do in the ng on destroy. So like this you need to destroy. The effect function returns an effect ref which has a destroy method that allows you to manually destroy the effect. In this example, what I will write, we destroy the effect inside the effect using the ng on destroy lifecycle to avoid the memory leaks. So summary, the total summary of this one which I want to tell you is, effects respond to signal changes and can be created inside components, directory or services using Angular's injection context. One thing, you can create effects in a component constructor or defer their creation by passing an injector object to the effect. That one also I have shown you in the initialize logging. Effects can be automatically destroyed when the containing context, component, directory, etc. is destroyed, or you can destroy them manually using an effect ref for more control. So this is all about the injection context in the effects thing. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will learn about the Angular signals equality function. How the equality, the signals treat, let's try to see it. So now I want to explain you the simple thing about this one. So here in the context of Angular signals, equality functions allows you to customize how changes to signal values are detected. So why? Because I will try to explain you with a simple example also for this one. So here you need to understand that equality function allows you how the signal needs to be detected to the changes. By default, Angular signals use the referential equality, that is nothing but triple equal to. In JavaScript we have double equal to and triple equal to, right? It uses the second one, that is triple equal to referential equality, to determine if a new value is different from the previous one or not. So if you want to, if it were, for example, let's say that you are having a signal and you are assigning a value to the signal, it will try to check with a triple equality function that the new value which you are trying to assign it to the signal and the old value, the previous value which you are having it, is both same or not. It will try to check it with a triple equal to reference. However, this approach only checks if two variables references the same object in the memory. So referential equality means, what is that meaning? So if it exists in the same memory and also it belongs to the same data type, same value, means then only it will try to check it. For complex data like arrays or objects, even if the contents are the same, creating a new instance of the array or object would not be considered equal using referential equality. For example, let's say that if you are having an array or anything object or anything complex data types, so if you are trying to assign the same value, then also the signal will not show it as an equal, because the memory object, because it both belongs to the different instance and the both memory location will be different. So that's why, because it is checking with the referential equality, triple equal to, so that is the reason. So both the value should not be will not be considered as an equal for complex data structures. Like primitive data types, it will be considered as an equal. So this is the first concept which I want to explain you. And the second thing is, equality functions can be provided to both writable and also computed signals. So now the equality function, whatever the equality thing we are trying to do, it can be provided to both writable signal and also computed signal also, to alter how the equality check is performed. This is useful when dealing with more complex data types where you want to compare the content deep equality rather than just the reference. So now so special type of functionality will be there in the signals, that is nothing but equality functionality. You can apply it both the writable and computed signal to alter the equality check. So by default the Angular uses a triple equality, right? So if you want to alter the changes means you can use it this one. This is useful when dealing with more complex data types where you want to compare the deep equality rather than just the references. So now first I will try to show you the default equality, how it will be. By default I told you that Angular signals compares values using triple equal to. This means that even if two objects or arrays contain the same data, they won't be considered equal because they have different instances. For example, let's say that here you are having the code in such a way that I will increase the font size for this one so that you people can able to see it easily. Yeah, let's say that for example I will delete this entire thing code. So let's say that I am having a data, okay, and here it will hold a value of something like test, okay. So it is holding a value test. So now what I want to do here, let's say that we will be having a constructor, okay, and here I will be using the effect, okay, and in this effect what I will try to do, I will do console.log effect executed and console.log this.data. So I will try to use the this.data so that whenever the data value responds to those changes, effect will be executed. Now for the first time if you try to check the output for this one, okay, so what is happening, so now the effect got executed and we are able to see the console.log of test. Now what I will do it is in ng on init, okay, ng on init, I will use a set timeout function to change the value of the signal after something around 4 seconds, okay. Let's assume that after 4 seconds I will try to change the value. So here I will be writing the console.log set timeout executes, and here I will try to change this dot data dot set, and here what I will try to do, I will assign the same value. So I am not changing the value, the previous value whatever it is having, the same value I am assigning it. Now here both the values are equal, right? So the effect should not be executed. Why? Because the value didn't change. The value technically if you try to say the value hasn't changed, but here if you try to see set timeout when executed, the effect got immediately executed. Why? Because the value has been changed. Even if the values are both equal also, here it will be, the effect will be fired because the signal will be trigger and update because the errors are of different instances. That means both are from different memory location. So in the above case, data.set of test triggers an update even though the content of the new array is the same as the previous one. This happens because referential equality checks whether the two values reference the same object or not, whether their contents are not whether the contents are identical. So that is one thing. So now if you want to use the deep equality function, so you can use the third party plugins or anything. So here I am using the lodash thing, so I will be executing the lodash, okay. So here for installing this one I will use npm install types@lodash. So I am installing the lodash, so that here I will be using the is equal lodash is equal method in order to check the deep equality test. Let us install this one. So lodash has been installed here. So now if you want to check the deep equality test means, then what you can do it is, here you need to provide equal of is equal, okay. So this one belongs to the lodash and here it has been installed from the lodash, fine. So now we have used it like this. Now if you try to see here, effect is executed for the first time. When the set timeout is fired, this time effect is not get executed. Why? Because so we are telling that if the content are same means deep equality test we are trying to check. If the content is same means we should not trigger an update. So this is the thing which I am trying to tell you. So you can provide a custom equality function when creating a signal. So here I am using a custom equality. So here the function can be anything. So custom equality function you can use it anything. So here if you want you can provide a function and you can use it here, something like that. So you can use it whatever you want it. So in this case I am using the lodash dot is equal. So if you want to, you can use your own custom functionality also, return true or false, something like that you can return it to perform deep equality checks, ensuring that updates only occur if the new vehicle is truly different in content, not just in reference. So here I have used, here the underscore the is equal function checks if the content of the arrays is the same or not. Since it compares the elements of the arrays and finds them identical, the signal does not trigger an update. So now the next one which I want to tell you is the writable signals with custom equality function. So you can also apply equality functions not only to the writable signals, also you can use it, allowing for customized behavior when setting the signal values. For example, the same thing if I want to apply it for a key value. So will it be applied means, so the object also it will be applied. Why? Because the lodash will try to check for the Lodash will try to check for the objects equality test also. So now here if I try to change the value for this one, key value, and here also key value, if I try to check it. So now if you try to see the output for this one, so now you will be able to see the key value has been defined. Now when the value is when the trigger is fired, so the effect is not getting executed. Not only for this one, so you can also apply it to the computed signals also. The equality functions are also useful when working with the computed signals. You can control when the computed signal should trigger updates based on changes to its dependency. For example, let's say that we are having a base signal and also a computed signal. So you can have it something like I will remove this data. Okay, so let's say that I am having a base signal is equal to signal of, so in this one I will be having an array of A comma B comma C. Okay, so this is the base signal, and here what I want to do is I will try to use a computed signal is equal to computed of, and here this is the method which we will be trying to write it. And in this one what I will do, I will return the this dot base signal only. So I will return the this dot base signal only. Okay, but here what I want to do it is, so here I will return I will console computed executes. Okay, so I will try to do it like this, and here if you use it like this you can use it. I don't want the effect, so here computed signal, we are dealing about the computed signal, and here I will try to do the base signal dot update, and here you will be having an array same values. I will try to push the same values. So now let's see that whether the computed signal will be executed or not. So now for the first time, so we don't have anything. So whenever we call the whenever we call the computed signal, after some time we call the computed signal, then it will be executed automatically. So I don't want to show it here. So if you want to use it means, so then what I want to do here also you can use equal. Okay, equal. So if you want to use it means, so I want to show you clearly means, then you need to use the here computed signal. That's it. So now this should be something like this. Yeah. So now if you try to see here, we are able to see the ABC and computed has got executed. So whenever you try to execute this one, set timeout execute, and immediately the computed also executed. So that means the computed value is executing again even if we assign the same value. But if you don't want to execute this one means, then what you want to do here, you need to use the equal is equal. So you can use this one. So now when you refresh this page, computed first time it execute to show the output, and next time it will not execute again. So again it got executed. Computed is equal. So based on this, so in this example, computed signal tracks of the base signal. When you set a new array with the same contents, the equality function prevents unnecessary updates even though the array reference changes. So here it is executing again. So why? Because because the both are equal. So let's try to refresh this page again. So we will check this one afterwards. So computed signal also, this equal thing also will work. So total in the summary, what I want to tell you is the default behavior. So first one is the default behavior of this one. Okay. So first one is default. Signals use referential equality, meaning any new instance of object or array is considered different even if the contents are the same. The second one is the custom equality functions. You can override the default behavior with a custom function like lodash is equal to perform deep equality checks, ensuring that updates only happen when the content truly changes. Writable and both writable and computed signal can take advantage of custom equality functions to fine tune the when update occur. So this is about the equality things, how the signal will check. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will try to see about the another important concept in the Angular signals. So that is nothing but untracked function. What is the use of this untracked function? So let's just try to understand about this briefly. In Angular reactive system, signals are used to manage and track state changes efficiently. So this is the normal definition. So all the time I am trying to tell you. When working with signals, especially within the reactive functions like computed or effect, it is crucial to control which signal reads are tracked as dependencies. So here what I am trying to say is, for example, let's say that you are using the signals concept, and signals means, so those are reactive things. So whenever you are trying to use these signals values in the computed or effect thing, let's say that in your computer or effect you are using more than one signal, so that means it is dependent on more than one signal. So if you want to control the dependencies, that is very much important, right? So that is the thing I am trying to tell you. By default, reading a signals value within such functions establishes a dependency. So whenever you try to read a signals value within this computed or effect value, affecting, it will make it as a dependency, causing the function to reevaluate whenever the signal changes. So that means, so whenever you are trying to use that particular signal value in a computed or affected function, automatically whenever the signal value changes, immediately that logic and everything will be reevaluated. So that is what I want to tell you. However, there are scenarios where you might want to read a signal without creating such a dependency. Sometimes let's say that you are having 4 signal values are there in a computer property which is dependent on that one. If any of the signal value changes means, then the computed value will be reevaluated. That means that computed value is dependent on 4 signal values. Any one of the signal value changes means it will try to execute. But I want only that computer property to dependent on the 2 signal values only. Other 2 signal values I want to omit it as a dependency. Then, so there are scenarios. So these type of scenarios are also available, will be existing, that you want to read a signal without creating such a dependency. So you want to read a signal in that computed value, but that computer property should not be dependent on that signal value. This is where the untracked function becomes useful. That is one thing. So understanding this untracked thing. So what is this untracked function? So the untracked function in Angular allows you to read a signals value without making it as a dependency of the current reactive context. So that means you can read the signal value in the computed or effect value, but whenever the signal value changes again, right, that particular signal value, if you use it in an untracked function, then that computed value will not be executed. So that means only one time. So that means you can able to read the signal value, but you cannot execute it again when that signal value changes. This means that changes to the untracked signal won't trigger reevaluation of the computed or effect function. This is particularly beneficial when you want to perform operations that should not react to certain signal changes. So I will try to show you some simple example how we can use this untracked thing. So here we will be having something like a let's say that we are having count, okay, which is equal to signal of 0, and we will be having another one is a name, so which is signal of, so I will be having Leela, okay. So these are the two, and what I want to do, I want to use a effect here. Inside this I want to use an effect. Okay, let's use the effect. Effect should be used in an injection context only. So in the constructor injection context it will be available. So that's why I am using it. So I want to use the console.log. Okay. So here I want to use count is, so I can use directly dollar of this dot count. I can use it like this. And name is dollar of this dot name. Okay. So these are the two things which I want to do it. So now what I want to do it here, so what I want to do it is, so now I want to track it. For example, let's say that we are having an ng on init, ng on init, and here I will be using a set timeout. Okay, so here in this set timeout I will try to change the value. So this dot count dot update of value, or otherwise set I will use it, set of, so 3 I will update it. So whenever you try to update it, after 3000 seconds it will update it. So when this one is finished, so I want to write another set timeout. So here also I will try to update the value, that is nothing but this dot count, not this time I will try to set the name dot set of, so Alice or anything, whichever the name I want to use it. So this timer should be executed after 6000 seconds, that means after 3 seconds this count will be executed. So we know that this effect is dependent on the 2 signal values, that is nothing but count and the name. So when the count is changed, it means immediately this effect will be executed. And also when this name is set, means this name is also dependent on this effect is dependent on the name, and again this effect will be executed. Let's try to see the output for this one. So if you try to see the output for this one, so let me refresh this page and go to the inspect element, and here in this one, at the first time this one is executed, and here you will be able to see at the second time the count has been executed, and here the name has been changed, again this one also executed. So that means In this example, the effect will re-execute only whenever the count changes, and also the name also changes, it will execute it. But I don't want whenever this change, whenever what I want to do is whenever this name is changed, I don't want to execute this effect. So that means I need to keep this one in an untracked. Okay, let's try to keep it as an untracked. So here I need to use the untracked. Okay, untracked. So I will be using in the untracked of this dot name. That's it. So now if you try to use this untracked, so this should be imported from the untracked here. Untracked. That's it. Okay. So now if you try to check it here, so here this dot string is not assignable to parameter. Okay, untracked. Let's try to see it. So here we need to give it as an function. So we should not use the value. Untracked takes the function as an output. Okay. It will take the function as an output. So fine. So now whenever I try to refresh this page, so now here I will try to do the console so that you can able to understand it very easily. Count triggered. Okay, and another time name triggered. So that you can able to understand it. So now when this effect will be executed, let's try to see it. So the first time the count is 0, name is Leela. Okay, fine. So the count is triggered. That's why the effect is also executed. Now this time the name is triggered, but this time the effect is not executed. So in this example, if you try to see, the effect will re-execute only when the count changes. The name signal is read using untracked, so changes to the name won't cause the effect to run again. That's it. That's the thing. So now you can check it in everywhere. So wherever you want to use it, so you can use it everywhere. This one. So now you need to understand that when to use this untracked thing. Okay. Avoid unnecessary recomputation. So whenever a computed signal or effect reads multiple signals, but you want to prevent certain signals from causing revaluations, so these places you should avoid it. And external code execution. When invoking external code within an effect, that shouldn't be treated as dependency. For instance, logging services or third-party libraries that read signals internally, then we can use this one. So now, not only this one, so we can also use it in the effect also. How we can use this one in the effect, I will try to use it. For example, let's say that the total thing should not be executed. Then what I can do, I can remove this one here. So I can remove for this one. So here I can use it as this dot name, and in this one, this dot effect. So here I can use it as an untracked. Okay, untracked, and this takes the function. So that means whatever the logic it is there inside this one, so everything will be untracked. Now like this also you can use it. Now here if you try to see, the first time the count is executed. So now whenever the effect count triggered, it will not do it. Now the name also will be triggered, so but the effect is not getting executed. So in this case, so the console.log, the untracked signal, whichever console.log might read signals internally. So it might read the signals internally, but by wrapping it with an untracked, we ensure that these reads don't cause effect to re-execute it again. So important consideration you need to understand is, so we need to use it with caution. Overusing untracked can lead to the code does not respond to the state changes as expected. Ensure that untracking is appropriate for your specific use case. Wrapping functions. The untracked function accepts a callback. Any signal reads within this callback won't be tracked as a dependency. So this is all about the untracked function in the effects thing. Hope you understood about this concept. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will learn about the cleaning of the effects. So how we can clean the effects thing. So I want to explain you about this one. So let's try to open this one very big. Yeah. So hopefully you'll be able to see. So let's try to see. So cleaning up the effect, cleaning up the functions. So normally what is the effects in Angular signals? So you people may be having a idea. Fine. So let's try to see what are effects in Angular signal. If I try to show you what are effects in Angular signal. In Angular signals, effects allow you to respond to changes in signals without returning any values. That is performing the side effects like logging, fetching data, or interacting with the DOM. Sometimes these effects need to be cleaned up when a signal changes or when the effect is destroyed. I will try to show you this one. So sometimes what we need to do when you write an effect for any signal value, sometimes we need to have a situation in such a way that we need to clean up the effect thing. So how we can clean up this one? So cleanup function in effects. So let's try to see. Cleanup function in the effects. So when you define an effect, you can optionally pass an on cleanup function. So you can optionally pass an on cleanup function. This function allows you to register a cleanup logic to be executed before the effect runs again or when the effect is destroyed. Example, navigating away from the component that uses the effect. So I will try to explain you some simple scenario regarding this one so that you people may have a clear understanding about this one. So let's open this code and also let's open here. And here when you try to see, so we have a computed signal, right? We have a computed signal.component.is file. So I will try to remove this entire code, okay? And here what I would try to tell you is, let's say that I am having a count signal, okay? Signal of 0. So this is the common thing which you people know about this one. So let's say that I am in the constructor. So we know that the effect, if you want to inject it, so you need to write it in a constructor, or otherwise you can mention it in the class property also. So here this is the thing, and here let's say that I am having a set interval, okay? So set interval, and this interval runs for every second, okay? For every second I want to run it, and here I will try to do the console.log interval effect execute, and here I will try to, okay, so here fine, right? Interval effect executes, and if you want you can write the this dot count value also, you can use it, so that this effect is dependent on the count value. And here in the ng on init, what I will try to do here, I will do this dot count dot set of 1. Immediately I will try to update it, and after some set timeout, okay? So after some set timeout I will try to execute it, okay? Or otherwise we don't want to have a set timeout also. For example, let's say that, so when you try to first time, effect will be executed. So here if you try to see, the effect got executed, so fine. So when I remove this component, what will happen? Will this interval runs again, or when this component is destroyed, will this interval runs again, or what will happen? Let's try to see it. So here we are defining this component in the app component.html, right? So let's try to have a button toggle. I will try to use toggle component, okay? And here I can use something like click on toggle component, okay? So let's try to have one method, and in the app.component.ts file I will try to show you in the app.component.ts file. So here this is the app component.ts file, yeah. Here I can have a component toggle is equal to signal of false. So at the time, first time it will be false, okay? And I need to have on toggle component. So whenever you are trying to do it, this dot component toggle dot update of value is equal to not of value. That's it, finish. So toggle component is also completed. So now at the starting phase it is false, so we need to add a condition for this one. So if you want, you can add something like @if component toggle is there, then I need to use this one. That's it. So now if I try to show, first time the computed signal component is not there, so that's why it is not showing any errors. And if I click on this one, the set interval started. So that why? Because the effect started executing for this one. This interval started executing. So now when I click on this toggle component again, let's try to see here. Still the interval is getting updated. So that means whatever the interval we are having it inside this one, so it is still getting executed. So here the effect creation, the effect function is created with a callback. And here what I can do here for opening this one, so I can use an on clean up. So this is the function, and here I can add something like on cleanup. So this takes a callback function, and here in this one, so you can have a constant timer is equal to, I can have it like this, and in this one I can clear interval of timer. I can use it like this. So that's it. So now when you try to use it for the first time, so when you click here, the toggling is there. So the toggling is happening. So 2, 3, 4, 5, 6 like this it is coming. And when I click on this one again, so what it is happening, the timer has been stopped. So that means the set interval got destroyed. When I click on this one again, it starts again from first onwards. See here it is starting again. So this is how actually the thing works. So effect creation, the effect function is created with a callback that takes on cleanup as an optional first parameter. This is useful when you want to clean up the resources like timers, event listeners or subscriptions. So whenever the effect runs again or it's destroyed. So inside the effect we have mentioned something like an set interval and all those things, and on cleanup. So whenever we are trying to use the on cleanup, so we are using clear timer. So the cleanup function ensures that if the effect runs again before the 1 second timeout is completed, the timer will be cancelled. So this prevents multiple timers from overlapping or causing potential issues with side effects. So that is one thing. So like this you can use in any ways, something like a window listener. So for example, let's say that if you are having a window means, then you can use this window also. For example, let's say that, so let's try to observe this example. So let's say that we are having an effect of on cleanup. Okay, so what is the problem for this one? On cleanup. Okay, I need to use another one. Okay, so now here we are having an handle resize. So here how this one is, the effects add an event listener for the resize event of the window. So whenever I am trying to window resize, so this event listener will be executed. So if I try to resize, if I am trying to refresh this page, so toggle it. So whenever I try to resize, see here you will be able to see resize is there. So when I try to remove this toggle thing, so then that resize will be removed. So here the effect is destroyed or reruns, the cleanup function will remove the event listener, ensuring that it doesn't remain attached unnecessarily. So what is the summary of this one is, so let's try to explain you one by one. So here, so now you understood about the cleanup thing. So when we use the cleanup, so when you define, the effects in Angular signals allows you to perform side effects that depend on the signal changes. Cleanup functions are registered using the on cleanup to prevent stale operations from continuing. Example, active timeouts, intervals or event listeners when the effect reruns are destroyed. The cleanup ensures that long running operations like polling or timers or something are cancelled before a new run, preventing memory leaks or unexpected behavior. So this is the use of the on cleanup in the effects thing. Hope you understood about this concept. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will try to learn about the another important concept in the signals thing, that is nothing but RxJS interoperability package. So what is this RxJS interoperability package? Let's try to see it. So RxJS we have another package which is in the developer in the right now in the preview in Angular 18. It offers some handy features and also handy packages for us. So handy methods for us. So what are those handy methods for us? Let's try to discuss it. So I am trying to remove this one all. So let's try to remove this one all so that we can able to understand it clearly. So fine. So here let's say that we are having this effect, right? So now the first method which I want to tell you is that toSignal. So what does this toSignal will do? The toSignal function. So first one is, let's try to open the Notepad++. Yeah, the first one, the first package available in the RxJS. So this one is RxJS-interop package. Okay, this is the package. It automatically it will comes in the Angular core, but this one is in the still development preview, but in the futures it may some changes will be there, but right now it is stable only. So now the first method which we will be having is the toSignal. So what does this package offers? Some methods I will try to tell you. The first method which it will try to offer is the toSignal. This function converts. So here what it will try to do is, why? Because we are using this package means, for example, let's say that you people are accustomed or habituated with the observables concept. So right now this new concept has been came. So there is nothing but the signals concept. Now whenever you try to use these signals and all those things, so then what about the observables concept? So you may be getting it a little bit confused, right? So that is the reason. So this package will be available for us. So what does this toSignal method will do is, this toSignal function converts an RxJS observable. Here you need to understand, it will convert an RxJS observable into an Angular signal. So if you are having an observable, then if you want to convert it into a signal means, then you can use this toSignal function. Signals are reactive variables in Angular that store the state and notify the app whenever the value changes. toSignal automatically subscribes to the observable and updates the signal's value as the observable emits new values. So that means the to signal will automatically subscribe to the observable and update the signal value to the observable whenever the observable emits a new value. So I will try to explain you the simple example. Let's say that here in our code, okay, I will be going into our code, and here let's say that here we are there in the computer signal, right? So I will remove this one all. Let's say we are having a counter observable. Okay, so I am having a counter observable, and this one is signal of this one is not observable, right? So let's say that I will create an observable which is an interval which should be imported from this one, and for every second it will emit a value 1 2 3 4 5 like that. So now I want to use this one in a as a signal. So then what can I do? So I can have a counter and I can use the to signal, okay, to signal, and this one right now it will not come, so you need to import from @angular/core/rxjs interop. So now here directly you can use the to signal. Here directly you will get the to signal which should be imported from this one, Angular core rxjs interop. Now here I can send the observable, counter observable, okay, and you can also pass some options to this one as an object, and those options means nothing but first one will be the initial value. So that means if the first time when you are subscribed to the observable, so first time it will not send any value, right? So until that you can use this initial value, and now I can use this counter thing in our computer signal like counter. Here you will be having counter, that's it. So it's a signal thing, so you need to use it like this. Now whenever you try to see here, for every second the value will be updated. So now the counter value, it's a signal thing and it is coming from the observable. So the to signal has subscribed to this observable, and this observable emits the data for every 1 second, and automatically the signal value is also getting updated. So here interval of 1000 is an RxJS observable that emits a number every second. You understood this one. The to signal takes this observable and converts it into a signal. The signal starts with an initial value of 0 and updates every time the observable emits. The template displays the signal value using the counter, which automatically updates the view as an observable emits new value. This is similar to using something like an async value. Whenever you try to use the observable, for example, if I try to use this counter observable, here you will be having this counter observable. If you try to see here, we can use the async thing. So this looks like something like async only, but here we need to import the common module here. Yeah. So now here if you try to see the same thing happens. See, the same thing, the async only, but if you want to use it with the signals concept, the new concept, so then you can use this to signal. So in order to, if you are having an observable and if you want to convert it to observable, means you can use the to signal. That's it. So it gives you more flexibility to use the signal anywhere in the component. And you have another option that is nothing but in the I told you, right, in the to signal we can have the initial value. So we also have another option. So now you need to understand about the manual cleanup. So the another option which is available is the manual cleanup. What does it do? So let's try to see it. So manual cleanup. Okay, so in this to signal only we have another option, manual cleanup. As we have already discussed about this manual cleanup thing when you are trying to read about this effects and all those things. Okay, not effects thing. So now what does it do? By default, when a component uses the to signal, it is destroyed. So that is to signal is destroyed. Angular automatically unsubscribes from the observable. So why? Because so whenever the component is destroyed or anything, it will be unsubscribed. However, you can override the behavior using this manual cleanup option, which allows you to control when to clean up from the observable. So that means when you are trying to use this option, so you need to manually clean up the option in the on destroy thing. So what can I do here? So here I will be using the manual cleanup to true. Okay. So I will be using the option something like manual cleanup to true. Here somewhere you will be having the option, yeah, like this, manual cleanup to true. Whenever you keep this manual cleanup to true, so what you need to do? So here instead of this one, the counter observable dot subscribe is there, right? So you will be having this subscription. Okay. So now what you need to do? So you need to unsubscribe to this one. So for example, let's say that subscription. So you can have this subscription. Okay. And you can have this subscription which should be imported, and now on ng on init you need to subscribe to this one. So here you will be having ng on init, you need to subscription to this one. So whenever you are having this ng on destroy, so you need to destroy to this one. So for example, let's say that here you are having, so if this dot subscription is available, so we need to subscribe, manually clean up the subscription like this. So in this example what we have to, we have set the manual cleanup to true. This means Angular will not automatically unsubscribe from the observable when the component is destroyed. So when the component is destroyed, the angler will not automatically unsubscribe it. So we create a subscription manual on ng on it and ensure it's cleaned up in the ng on destroy. This approach is helpful when you are working with the long-lived observables or observables that naturally complete on their own. So that's the thing where we will be using it. And we also have another option that is nothing but error and complete handling. So what does this does is when you use toSignal, if the observable emits an error, that error will be thrown when you try to access the signal. Similarly, if the observable completes, the signal will continue return the last emitted value. So for that one, what you need to do it is, so for example, let's say that you are having an observable. So just you can catch it with the catch thing. So let's say that you are having an observable and you are having a value something like this. So you can take it like this. Let's say that I will try to remove this one all so that you will be able to understand it. So here I am having an error message. So I am in the observable I am throwing an error. Okay, throws an error, and here you will be having an initial value. So here you will getting an error. Why? Because so we are trying to send the wrong value, right? So now when you try to use this ng on in it, so you can directly use this one. Okay, so why? Because so directly it is throwing a value, so that's why it is showing an error. Okay, so now why? Because it cannot able to understand the default value of this one. So never. So here toSignal, and when this error throws an value, so we are trying to calculate the signal value. When it is throws an error, we are able to calculate this one. So now here you can, what you can do the error message and you can remove this one, and here you can show the error message. That's it. So now if you try to see the output for this one, so you will be able to see counter an error occurred. So like this, whatever the error you are trying to do it, so you can throw error. So like this you can catch it. So this is what I want to tell you. So the throw error observable emits an error immediately. The toSignal is called. It converts this observable into a signal. The error is thrown when the signal is accessed, and we catch it to display the error message. This pattern allows you to handle errors gracefully in your UI. Similarly, how would you handle some errors in a regular RxJS subscription? So this is all about the toSignal concept which we will be using it. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will learn about the another important concept that is nothing but toObservable function. So what is this toObservable utility function? Let's try to have an overview of this one. So toObservable is a utility in Angular that converts a reactive signal into an observable. So that means if you are having a signal in your Angular, if you want to convert that signal into an observable means then you need to use the toObservable. This allows us to take the value of a signal which is used in Angular's reactive system and use it with the RxJS operators like switch map, map, etc. Essentially, it lets you to integrate Angular signals with the RxJS. So now let's try to understand the key points of this one. So monitoring the signal changes. So when a signal value changes, the toObservable utility tracks the changes using an effect and emits the updated value through the observable. This is helpful for integrating signals with asynchronous streams like HTTP request. And another one which you need to understand is the injection context. So the toObservable relies on the injection context. So that means the toObservable function will work only in the injection context. That means example, a component as a service in the constructor or something like that. If there is no automatic injection context, then you need to provide an injector manually. So now the next one what I want to tell you is the on subscription. Okay, next one is the timing thing. On subscription, the toObservable might emit the last known value of the signal immediately if available via a replay subject. Signals don't emit the values. So here whatever signals don't emit values synchronously like observables do. Even if you update a signal multiple times in a quick succession, only the last stable value will be emitted. So that means when you have used a toObservable, the last emitted value only will be sent. So I will try to tell you a detailed explanation with the example. So now, for example, you want to monitor the value of a signal called something like a query or something like service. So let's try to see the simple example for this one. So here we are having this symbol, this one, right? So at the top of the component, let's say that I am having a service. Let's say class query service. Just I will write it here only so that we can able to write it. So I am having a service, something like class query service, and this has a value something like query is equal to signal of empty value. So at the starting of this one, so this one is an empty value. Now what I was trying to do, so here it is an empty value, a signals that holds the search query string. So let's go to here into this one. So here what I will try to do it is, here I will have a div, and in this one I will have an input element. Input type is equal to text. and here what I can do it is, so I want to listen to this value, so that means I can use an input. So just whatever the thing you want, you can use it in ng model. So we haven't covered this ng model, so ng model we have covered it, but that was all things we covered. So I will use the input on query change event, sorry, dollar event, it should be dollar event dot target dot value. Okay, so here this is the query change we are having, and here at the bottom I will try to do the ul, and here I can have an li. So here we can use the @ for loop. Okay, for item of items. So let's say that for result of results dollar of async, I can have it as an async. So track, what you can do it is results dot async. Okay, and here you can use something like result only. Okay, so you can use the result only as the value, and here I will try to do is, so I will use the result only here. That's it. So this is the code which I want to do it. So now we need to have these all the values, right? So let's try to have it. So now let's go into here, and here I will try to do something like, so here we will have a query is equal to, so we will inject the query service, and in this one I will try to take the query value. Okay, so this is our signal thing. So it should be a signal of string. So here you will be able to see component which is a writable signal of string. So correct, it's correct. So now what I want to do is, I want to convert this query into an observable. Okay, so query dollar is equal to two observable. So I can use two observable. It should be imported from the Angular core RxJS interop. So here I can pass the query. Okay, I can pass the query. That's it. So now this query dollar is an observable, whereas query is a service, a signal. So now let's try to have results. Okay, so results dollar. So I am trying to get the results dollar, and this one will be this dot query dollar dot pipe. I can use the pipe symbol or anything, whichever you want, you can use it. And here I will be having the switch map. Okay, in this one I will be getting the query. Okay, and here I can return something like off of the query value, we will be getting it, right? So I will return the off of query. So just I want to show you that we will be returning the observable here also. So that's it. So now here we can use the switch map and all those things. Just I am trying to explain you. Here you can use an HTTP signal or something like that. So now whenever the query is changed, on query change. So this is the method, and I will be getting the value which is of type string. And here what I will do, and I will try to set the query dot set of value. So that is nothing but value. So this is the value I am trying to set. So now let's go to the HTML. So here everything is been set, but here we are getting it as event or target, or otherwise what you can do it is, so here we can get it as a dollar event, and on query change what we can do it is, so I will try to take it as an event only, and here I will try to take it as an event. So let's keep it as an event, and here event dot target, okay, dot value. So here we are not getting as in, here you can do the type conversion as input element, or we need to use an HTML input element. Okay, so this is all, you can keep it as something like this, and here we need to use the dot value. That's it. So now here like this also you can do it. So because of the type conversion and all this, here also you can use the same thing, but here I have converted it as an event or event, and event dot target, which you know that you are getting it as an HTML input element. That is nothing but in HTML we know that this is an input element, so that is the reason we are getting it this one. Now what we can do it is, on query change we got the value. So let's try to see the output for this one. So here I am refreshing this page. Okay, so right now computed signal.ts is there, app component, app computed signal also we are using it. Let's try to see the inspect element. Is there any errors or anything? Okay, so here we are no query service, no provider for the query service. Okay, so we are injecting the query service, and here we are having it. Okay, so let's try to see the output for this one. Okay, so here we need to use the injectable, maybe I need to use the injectable, I think. So it provided like this. Let's try to refresh this page. still we are getting no provider for the query service. So maybe I need to use this one, provided in of root. Okay, so let's try to refresh this page. Maybe now, right now I am able to get it. So now whenever I try to see the value for this one, see here, whenever we are sending the value, we are able to get the output for this one. So now this is how the two observable will work. So let me try to explain you. So here the query service holds a signal query that represents the current search item. We want to trigger a search results based on this item. So here we are having a query dollar. So which converts the query signal to an observable using the two observable. This observable will emit a new value whenever the query signal changes. And the result, this is an observable that depends on the query dollar. It listens to changes query dollar and uses the switch map to send an signal. So now input handling on query change, display of results, these all things we have seen it. So timing behavior, let's focus on the timing aspect. If you update a signal value multiple times rapidly, only the final stabilized value is emitted. So let's I will try to demonstrate you. For example, let's say that I will refresh this page, and in this console, let's say that rapidly I am trying to emit the value here. So if I emit the value, if you try to see here, see now, okay, so that is the duplicate values. For example, let's say that we are having on query change, we are having it, right? So let's say that on ng on init, okay, ng on init, okay. So now here I want to set the query value, this dot query dot set of something like A, and I will try to set B, and I am setting the values immediately I am setting the values for the signal. So that means at the starting time, so you will be able to get the value ABC, right? So now if you try to see the value, so here you will be able to see only the C1. So that means here the timing behavior is important. So why only the C is logged? The two observable waits for the signal to stabilize before emitting the latest value. Even if you update the signal multiple times in the quick sessions, like a set of A, B, C, something like that, only the final value C will be emitted once the signal has been stabilized. So that is the reason you will be able to see only the C option. So you will not see the A, B. And the next one is the injection context. In most cases, the two observable is used within the injection context only, such as inside a component or a service, where the Angular can inject dependencies. If you are working outside of an injection context, means you already know that you need to provide the injector as needed, but this is typically handled automatically on the components. So totally overall, in the conclusion, what I want to tell is, so two observable provides a bridge between the Angular signals and RxJS, allowing you to treat signals like observables for more complex and reactive use cases. It helps you react to signal changes asynchronously and stabilizes updates to avoid unnecessary reactivity. In this example, we have sufficiently handled the queries and all those things. So by using the signal value. Hope you understood about this two observable concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, in this video we will try to learn about the another important concept, that is nothing but output from observable and also the output to observable. So what is the difference between these two? So I will try to explain you about this one. So for example, let's say that I will try to remove this entire code, okay, so that we can have a clear understanding about this one. Oh, sorry. So I am removing this entire code, and here also these all the things are not necessary. In our app.component.ts file also, so we have added so many components that we are not using it right now. So up to here, and also this entire code is also we are not using it. So I will try to clean up this entire thing so that it will be clean. Here also I will try to remove this entire thing so that you people can able to understand it. Yeah, so this is our code right now. Let's say that, for example, let's say that we are having an observable. So name change dollar, okay, is equal to new observable of, and we will be having an observable. And in this one, what I will try to do, here this is an observable, and here I will try to use a counter is equal to 1, and I will use a set interval, and for every interval of time, for every 2000 second or 1 second only will try to make it. And here I will try to emit the object. So observer dot next of name change, name has been changed, and also I will be using counter plus plus. So I will use all the time counter plus plus. So this is the observable we are having. Now what I want to do it is, I want to send this observable data as an output. So that means, so that here I can capture it. How can I send this one? So that means here I need to capture it that in such a way that name change is equal to on name change. Okay, so like this I need to capture it. So here dollar event, let's say that value we will be getting it, and here on this name change, what I want to do here in the app component.ts file, so here I can have a on name change, and you will get the value as a string, and you can do whatever the thing you want, something like let's console.log of value. Okay, so this is the thing which I want to do it. Now if you try to see here in app component, so I am trying to get the dollar event. So here we need to send the event. So here we are right now we are having an observable. So what can I do here? So one thing is, what we can do it is, so I can create a name change is equal to new event emitter of string. Okay, so of string, and so we will be having it like this, and we need to make it as an output here at the rate output. Okay, so here we will be making it this one, and if you want to send it something like that, means we can do it something like this dot, we can do it, I think this dot name change dot emit of, and we can change it, we can send it this one. So we can do it in such a way that something like this. Okay, sorry, so one way is something like this, we can do it. So now if you try to see here in the code, if I try to refresh this page, let's try to refresh this page so that we can able to get it or not. Let's try to see it. So we are not able to get it. So this dot name change dot emit, and here we are using it on name change. So this one will write name change. So now if I try to check this output for this one, so we are not getting the output. Why? Let's try to see the output. Let's try to see. So we are doing the name change on name change, and we are able to consoling the value, and here we have created observable, and we are trying to emit the value. But here what we need to do, so in order to get this one, so we need to subscribe to this one, so that at least one time it will be executed. So ng on init, and here I can do this dot name change dollar dot subscribe. So now I can able to get the value. So now here if you try to see name change 1, name change 2, 3, 5, so some of the values are getting missed. So here I can able to get the value. Oh, why? Because counter plus plus, 2 times I am using the counter plus plus. But these all the things is boilerplate. For example, if you are having your own observable, so if you are having another observable coming from someone else, so you cannot write this code inside this one, right? So in order to have this one, so we can remove this entire code. Okay, we can remove this entire code, and we can use an method that is nothing but output from observable. So that means we are trying to create an output from an observable. So right now we have an observable, and we need to create an output. So that means what can I do it here is, so name change, I can use a variable name change is equal to output from observable. So right now we are not getting it. So here I will remove this one. So here I need to get it as @angular /core/ rxjs interoperability. So here I can use the something like output from observable, and I need to send the observable this dot name change dollar. That's it. So now if you try to see the output for this one, so let's try to see the output. So the same output you will be able to get this time, but this time so we are able to get, so why? Because this one is coming again counter plus plus, I have used the same thing already. Let's try to refresh this one again. 1 3, oh, why this one is coming again? Let me try to check. Type unknown name change of event. Okay, so here why it is coming is, so we need to keep it as a string here. Okay, hopefully this one will resolve. Yeah, it has been resolved, so it's unable to recognize. So now we are able to get the value 1 2 3 4. So what we have did it here, so we have did nothing. So what we have did it is, so here we have used an observable. So that means you have any observable. So if you are getting any observable from anywhere, so if you are getting any observable, so if you want to convert that observable into an output means, so you can use an output from observable. And here you are getting an so non change event, right? So this is an output, right? So we have another handy method that is nothing but output to observable. So that means, so whatever the output you are getting it here, so you can convert it to an observable in the app component.ts file. So how we can convert this one? So let's try to show you. I will try to show you. So let's say that I want to convert into an observable here. So here let's say I will use the same name change dollar here. Okay. So name change dollar, it is of type observable of string. Okay. Now what I want to do, so this is an observable of string. So what I want to do it is, so here I need to capture this computer signal. I need to convert whatever the output value coming here. I need to convert into an observable. The output value I want to convert into an observable. So that for that one, what I can do is I can take it here. I can have a view child here, computed signal. Okay. So now let's try to go here in this one. So now there is no need for this one all. So here you can have a view child of, and here you can have a computed signal, and this is of type computed signal component or null is equal to null. So like this you can have it, and here you need to provide the same thing as a name here. Okay. So now we got this one. So now when this one is initialized, mg after view init. Okay, when this one is initialized, so now if this dot computer signal is there, so this one is for safety purpose. Now what can you do? So this is our name change dollar, right? This dot name change dollar, okay, sorry, this dot name change dollar is equal to output. Okay, we will be getting an output. So you need to convert into an observable, and you need to send, I need to give the observable. That observable is nothing but this dot computer signal dot name change. So this one. So this is the output you are getting it from the component. That is nothing but here in this one. This one is the output from observable. So this is the output you are getting it, and you need to convert it into an observable. Here, like this you need to convert it. So that's it. So this dot name change dollar output to observable. Now this has been converted. Now whatever the thing you will be having name change dollar here. So here you can use it something like do, and here you can write it something like, sorry, name change dollar to async. So whatever the value you are getting it here in this one, the output value. So now you will be able to receive the same value. So if here you will be able to receive the same value. This is how we will be implementing the output from observable and output to observable. Simple thing, you need to understand simple thing. Output from observable means, so you are having an observable of data and you want to send it as an output event emitter to the component, parent component means, then you will need to use the output from observable. It is a handy utility function. And you are having, for example, let's say that you are having a pay component here, and this component is receiving an event emitting data, and you want to convert that event emitting data into an observable. Then you need to use the output to observable. That's it. So this is a simple thing only. So this is how we will be using the output from observable and also an output to observable. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will try to see about the signal input. So what is the signal input and how it works, and their advantages over the traditional input, and how to implement them with clear examples. We'll try to see it. So overview of this one. So let's try to see about the overview of this one. So signal inputs. So normally the signal inputs are a feature in Angular that allow component values to be bound from parent components. So whenever you are trying to send a props values from parent component to the child component, normally we use the input decorator, right? So the same thing, the feature, it is another feature available in the Angular, that is nothing but signal inputs. These values are exposed using a signal which can change throughout the life cycle of your component. This feature is currently in the developer preview, soon in the Angular 19 or something like that, so it will become stable. So before that we will try to learn it, that one. So now the key features of signal input. So normally the input values, normally if you take it, means there are two types. There is nothing but one is optional and another one is required. So what is the difference between these two? Optional inputs means these are by default optional inputs. Optional input means these are, so by default inputs are optional unless specified otherwise. You can provide an initial value or it defaults to undefined. Required input means these inputs must have a value and are declared using the input dot required. So let's try to see the implementation example for this one. So for example, let's say that here we are having a computed signal, okay, So in this one, what I will try to do it is, I am trying to remove this entire code, and in the HTML, oh sorry, this one is here in our computed signal file, I will try to remove this entire code, and here in our computed.html also I will remove this one. Okay, fine. So now in this one, what I will try to do it is, so let's say that, so we will be having the input, three types of inputs. One is an optional input, let's say that. So that is nothing but first name is equal to input. Okay, so this should be imported from the where we need to import it, this one from the Angular core. Okay, so input of, and I will try to keep it like this only, and by this one will have a value of something like string. Okay, so the second one which you will be having is the age is equal to input of 0. So this one is also default value. I am trying to give this age thing, so input signal of number, this one. So first one will return, if you doesn't return any first name means it will return undefined, and this one you will be having a default value. And now the third one which I will try to write it is the required field, that is nothing but last name, and here I can write its input dot, so here I can use the required, and this one will take the string. Okay, and here it should be something like this. So last name will be input dot required string. So these are the things. So now these are the things which you will be having. So now let's try to implement this one in the what I want to say is in the HTML. So here I can have a first name, and here I can use it something like first name. Okay, and here you will be having the last name. So here you will be having the last name, and here also you can use the last name. And another one which I will be having is the, let's try to remove this closed one before this one only. Yeah, and another one which I have is the age. So you can mention the age also. So I will try to mention the age. Let's try to see this one. That's it. So these are the three things which I will be trying to do. So now here the first name is optional thing, and the age is an optional which is initialized to 0, and the last name is the required input that must have a value of type string. Okay, so let's try to have it in the app.component.ts file, so where you will be trying to use it. So in the app.component.html file, so I can remove this one, and I can remove this one also. So in the app component, here I need to send the first name value. So okay, so let's try to send the first name is equal to, so let's try to first implement this first name and all those things. So here I will remove this entire code, and here I will be having the first name value is equal to something like John. Okay, and here I can have a let's say that last name is equal to Doe, and the last one is the age which is 25, let's assume. Okay, so now in our app.component.html file, so here I can send the first name, and the last name I can send it, and last one is the age. Okay, sorry, age, that's it. So now I am trying to send the each one. Let's try to see the output for this one. So if you try to see the output for this one, so you will be able to see the input signal John Doe and 25. So why we are able to get this one is, so here as usual, so these are all signals, right? So you need to mention it like this, then you will be able to get the value. So it will be responded to the values. That's it. So now let's try to refresh. So we are able to get this one. So we can also alias the input names also. If you want to alias the input names, so we can also alias the input names. So how you can alias this input names is, so for example, let's say that computer signal data. So for age you are having something like 0, right? So you can keep another one something like alias. Okay, here you can have a student age. Okay, and now so you need to send this alias name in our this one as a student age. That's it. So now you can use it in your component as age only. So this is one thing which I want to try to explain it to you. So this one so optional input required inputs is completed. So aliasing an input also, so this allows users bind to your input using student age, while inside your component you can access the input using this dot age. So now in the templates we have seen it as a signal, we can use it. So now another one which I want to explain is the deriving values. As with signals, you can also derive values from inputs using computed. So if you are having any other value, derived value means, so just like the computed which we have learned it, so you can also use it that one. So for example, let's say that here you are having a age multiplied, okay, age multiplied, okay. So you can have a computed value, and here you can do something like this dot age into 2. So this is the multiplied value. So whenever the age changes, so here it will be changed. So now if I try to use this one, so multiplied age, here I can use it, multiplied age I can use it here, and here you can use age multiplied, that's it. So now if you try to see whatever the age is there, so here the age will be into 2. So computer signals by default it will memorize the values, so we can able to see. And monitoring the changes. When signal inputs, users can leverage the effect function. The function will execute whenever the input changes. Consider the following example. So let's try to do the same example. So let's try to go here. So we know that the computer, the effect and all those things work in the injection context. Okay, let's try to go to the constructor, and in this constructor what I want to do it is, and here I can use an effect, okay, and here I can use something like console.log of this dot first name, that's it, finish. So now if you try to check the output for this one, so you will be able to see the console.log for this one. Why this one is not executing? Is there any wrong that I have written? In the constructor I have written, in the effect I have written, and I am trying to do the this dot first name. So now we are able to get the first name. So is there any effect put or error or what? So nothing is there. So let's try to see it again, the output for this one, another version of DevTools. Okay, fine, that one is leave it. Let's try to execute this example, attempting initialization. So why this one is not executing? Every time this will happen as soon as the first video, the for success during the line type. So the problem here we are able to see it is the constructor, the spelling mistake. So this is the common problems which you will be able to face it. So here we are able to see the first name. So this one is the constructor, okay. So now we are able to get the derived value also. So why we need to use the signal inputs over the input? So reactivity, first one is the reactivity, second one is the type safety, and the third one is the derived values. You can easily compute the values using using computer property. Conclusion. So signal inputs in Angular provide a powerful and flexible way to manage component inputs with reactivity. By utilizing the input and the input.required functions, you can create components that are more resilient and maintainable. So the above example which I have told you, so how to declare and use them inputs effectively, and even making Angular even more capable for building reactive applications. So hope you understood about the signal inputs concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will learn about the another small important concept in the signal inputs only, which I have forgotten in the previous video. That is nothing but value transforms. What is this value transforms? Value transforms allow you to parse or coerce the input values without changing their intended meaning. They convert the raw values from parent templates into the expected types for your component. So that's the thing. So for example, let's say that here you are having something like example I will try to show you. So this is the example. Let's say I am having a do, and here I am having a disable. So let's try to, I will try to show you the disable, and here I want to show the disable thing. Okay. So here what I can do it is, I can show the disable. Okay. So now what I want to do it is, so in our computed signal.component, so here let's say that I will be getting a value that is nothing but input value disabled is equal to, it's an input, but I want to transform the value, so I can transform it. So that means I want to change the type of the value, I want to check the type of the value, and I want to change the type of the value. So the default value will be false, and here I can transform it something like transform, okay, and transform will take the value, so which is of type boolean or string. Okay, so that value which you will be getting, it is of type boolean or string. So then what I want to do, I want to return the value in such a way that if value is equal to string, okay, if type of value, sorry, if type of return type of value is equal to string means, then what I want to do, I want to return the value is equal to empty. So that means nothing but the true value, or otherwise I will be sending the only the string value. So here this is the thing. Here this is the value which I was trying to transform. So that means now let's say that in our app component.ts file, so whenever you want to send the data, you will be sending the disabled value. So here if you try to send the disabled value for this one, automatically it will be sent, it will be transformed. So let's try to show you that one, app.component.html file, and here we don't have these all the things, and here I can send the disabled, okay, is equal to some value I am trying to send it. Okay, so here I will try to send the string value something like this. That's it. So now if you try to see the output for this one, so here you will be able to see the disabled as false. So fine, right? So now like this we will be able to see it. Why? Because if it is equal to if it is equal value means I will be trying to send the false thing. So fine. So now we are able to understand about this one. So now what I want to tell you is, sorry, I need to use it something like a disabled. So here I need to take it as a disabled. So now this one is a normal attribute, right? So now here if you try to see, it's a disabled is true. So we are able to get that value. So like this we will be able to get that value. So now for example, let's say that if you are trying to send some other value, something like this, then we will be able to send the value as false or something like this. Fine, right? So now this is how we will be sending it. So now input for what, let's try to understand this example. The disabled signal input accepts either a boolean or a string. The initial value is set to false. Okay, and this transform function checks if the incoming value is a string. If it is, it checks if it is an empty string and returns true, indicating that the component is disabled. If the value is not a string, it simply returns the value result in the component. So inside the component you can call this dot disabled or something like that to get a boolean value without worrying about how it was passed it from the parent template. So important note on the transform is, so transform should not change the meaning of the input. For example, they should only convert the types but not alter the underlying logic of what it represents. And pure functions, transforms always must be a pure function. This one always should be a true function, pure functions, meaning that they should not have side effects or depend on the external state. So when to use this, so then if you are able to understand this transform, right? So when to use this computed or effect then? If you need to change the meaning of the input or perform actions that should run when inputs change means, then we need to use the computed property or the effects. So that's it guys about this transform thing. So now you may be having a doubt that what is the benefit of the signal input over the @input decorator. So this is the common doubt which you people may be having the doubt. So I want to explain you that one. So first one is the type safety. Signal inputs provide better type safety as they don't require you to give initial values or use workarounds to convince the TypeScript that an input will always have a value. And the another one is the automatic transform checking. So the next one is the automatic transform checking. Transforms are checked automatically to ensure that they match the expected input types. And automatic change detection. Okay. So when used in templates, signal inputs automatically mark on push components as dirty. So that is one thing. So derived values. So you can able to use derived values whenever input changes by using the computer properties. And local monitoring with effects. You can use the effects to react to the changes in input values without relying on the ng-on changes or the setters, leading to more localized and easier to manage the code. So this is all about the signal inputs. So hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will try to learn another important concept in the signals. That is nothing but overview of the model inputs in the Angular. What is this model inputs? Model inputs are a new Angular feature which is currently in the developer preview that allow two-way data binding directly within a component. So that means if you want to apply a two-way data binding in the component means then we need to use the model input. This means that a component can both read and write values to a property bound from a parent component, enabling the propagation of new values back to the parent. Normally whenever you get a value from the parent component, so what will happen? So you can only send the one-way data binding and only you can send the data to the child component only. In return, if you want to modify that input value means we cannot modify it. We need to do a output event emitter so that that value will be changed. But if you want to change the value which is sent from the parent means, then we need to use the model input instead of the standard input. So let's try to understand about what is the key differences between the model input and also the standard input. Let's try to understand it. Key differences between model input and the standard input. Model input. These allow both reading and writing of the bound values. The component can modify the input and the parent component will be notified of the changes. Whereas the standard input, these are only read only for the child component. The parent passes a value but the child cannot directly modify it. This is the common thing. Whenever you are receiving data with the input decorator or the input means, it's a only read only, you cannot able to change the data. So I will try to show you a simple example for this one model input so that you can able to understand it clearly. So I will be creating a model input and also a standard input. When defining a component, you can create both model and standard input using the model and input functions. I will try to show you. First of all, let's say that we are having a computed signal, the same thing. I will be using this one only. So here, let's say that I am having a checked. Okay, it is which is of a model input. So I will be trying to do it as a model of false. Okay, this one is the model input. And what I will try to do it is I will define a standard input also. This is a model input with the default value of false, and I will be implementing the standard input also with the default value of false. So disabled is equal to input of false. Okay, so this one is also, it should be imported from the Angular core. That's it. So I will be having another method that is nothing but toggle. So which I will try to set the model input value. This dot checked dot set of, and here if you want you can use the update, and here I will use the value, okay, not of this dot not of value. That's it. So now I am trying to update the model. So here checked means this is a model input that allows the two-way data binding. That means parent component can bind to it, and this component can update the value. So that means the parent it can update the value. Whereas a disabled means it is a straightforward standard input which allows only one-way data binding from the parent component to its child component. So now how we can use this one in our parent component, or otherwise let's say that, for example, let's say I want to explain you clearly about this one. So how can I use this one? So for example, let's say that this is the computed signal, right? So in the HTML, how can I write this one is, let's try to write here div, and here I will use the click, okay, is equal to toggle. It will try to do the toggle, and here I will be using the checkbox. Okay, so whenever I try to do the checked thing, so if the checked thing is there means then I need to use checked, okay, or otherwise it should be something like unchecked. So just I was using the value. That's it. So this is the thing which I want to do it. So now we have implemented that one also. Now in the parent component, let's try to implement this one. So let's say that in our app.component.html file, so here I will be using this app computer signal, that's nothing. And now I want to send the data. So here I will be checking, let's try to implement some values in this one app.component.ts file. So here this is the app.component.ts file, and here I will remove these values. So in this app.component.ts file, so what I will be having is, I will be having a parent checked, okay. So parent checked, which I will be trying to send it, is equal to, it's a false, so direct value, state managed in the parent component. And also you will be having is disabled. This one is also of type false. Now whenever you are having a handle checkbox, I will be having another one, something like handle check. This dot parent checked is equal to new checked value. So I will be getting the new checked value. So now what I want to do it is, so here if I want to do it is, this one is, so here for this one what can I do it is, so here in this app signal, so I can send the value of checked, okay, and here I can use the parent checked, okay, and here I can use the disabled. I will try to explain you each one. So what I was trying to do is disabled, and here I will be having checked change, okay. So this one is an event emitter checked change which will be changed for, which will be sent by the what I want to do is by the child components, and here I can use something like handle change checked of dollar event. Okay, that's it. And if I want to disabled, okay, and I want to check the parent check state in the parent component, so that is nothing but I will check it like this. That's it. So now if you try to see the output for this one, so here this one is an unchecked and checked in parent is false. If I try to click here, see unchecked and the parent here it is the true. So if I try to click on this one, so it is false and it is true. It is false, it is true. So now we are able to change the value in the parent component also. So what I was trying to do it here, so let me try to explain you the concept for this one is. So now we have used it in our this one only, this one also, right? So now let's try to explain you. I will try to explain you. So now the checked property in the custom checkbox is bound to the parent checked property of the parent component. So this one you are able to understand, right? The checked change is the event that will be triggered when the value of the checked changes in the custom checkbox. The handle checkbox change method in the parent updates the thing. So now inside the custom, inside this, what I want is custom signal, computed signal component. So when the toggle method is clicked, a click event in this case, so the value of check will change because it's a model input. The new value will be propagated back to the parent component automatically. So now in the parent component, the checked change event listener will detect this change and update it. So here what it was trying to do it is, so whenever you are having a model here, so automatically it will be having something like a checked value, and also it will try to update the value automatically whatever the input value is there. So you will be having a change as the prefix to this one. So that means every time you will be having the change as a prefix here, so that you can able to update the value. So if you don't want this one means, so then what you can do it is, so you can add an ng model type of thing. So here you can add the ng model type of thing, so that so you can able to implement automatically the same type of implementation, you will be able to get it. So for example, if I click here, see, then also I am able to update the value. If I try to refresh this page, so now the two-way data binding has been applied to this one. If you don't want the two-way data binding means, then automatically a change, so whatever the name is there, checked, and a change will be automatically as a suffix it will be added. So that is the thing you need to understand. So this is what I call as an model input. So this is called as a model input. So what is the benefit of this one? Model inputs are useful for two-way data binding within components. This allows the child component to both read and write the inputs value, automatically notifying the parent when the value changes. This step simplifies data flow between the parent and child components, especially in the reactive context. So hope you understood about this one. So we have already learned about this one in our Vue.js or React, or in the Angular also we have seen at the starting time. So if you want to send the data in the component like that. So hope you understand about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will try to learn about the another important concept, that is nothing but signal based queries in Angular. In Angular, signal based queries offer a way to retrieve the, so I will try to explain you basically in the Notepad++. So in Angular, signal based queries offer a way to retrieve and interact with elements, components or directives in a components template view or projected content. So that is nothing but view child or content child we will be using it, right? So that is the thing which I want to tell you. The signal based queries also, it will try to extract the element or component or directive which is provided in a component template or and also in the projected content. That is nothing but ng content. But the main difference between signal based and also a traditional decorator, which we will be using @view child, @content child, right? So the difference between signal based and is that signal based queries return a reactive signal object, enabling you to interact with them with Angular's reactivity system. So that is the thing. So you people already know that the Angular normally it provides two main types of queries. That is nothing but first one is the view query. These react results from the component's own template, and the content queries. These retrieve results from the content projected into the content. So let's go through the step by step. First we will try to see in this video about the view queries. So I want to explain you about the view queries. Then afterwards we'll go in the content queries in the next video. First one is view queries. So what is this view queries? So I will try to paste here. View queries let you retrieve elements or components that are part of the component template. The first one which you will be using is the view child, querying a single element or a component. The view child function retrieves a single result either by a string reference template variable or by the component directive. So I will try to show you a simple example how we can able to get it. So let's say that we are having here in our app component, so we are having a app computed signal, right? So this is the element, and let's say that we are having another element that is nothing but paragraph element. So here I will try to give hash el. Okay, so this is one is a component and this one is an element. So if you want to capture this one using the signal based thing, how we can capture is, so here I can provide in such a way that, so I can remove this entire code. So how can I provide this one is, so for example, let's say that you will be having div element. So if I want to get the div element is, so we can use directly the view child directly here like this. I can use it. So which will provide the element ref. So here signal of element ref, and here I can provide the el. Okay, and the another one which I can do it is the component. So if I want to get the component means I can get the view child. So I can do the view child, and here I can get the computed signal component. That's it. So now you will be able to get the two components. So these are the two components. Here el means this is a template variable, reference variable assigned to the paragraph element. You can use this reference in your view child query. And also view child of el means this query returns a signal. So here el means this query returns a signal that will emit an element ref of the div element. And this one is a component. This query looks for a child instance of my component in the template. In both cases, the query returns a signal object, meaning the result is reactive. When the element or component becomes available, the signal will emit the updated value. So if you want to check it means, so you can use it in the ng or init or anywhere, wherever you want, you can use it. So normally in the ng or init, you will be not able to find it. So here in the constructor, okay, so you can able to have in such a way that effect, I can use the effect thing, and this effect I can do the console.log this dot div element, and also I can do the console.log this dot component, right, component. That's it. So I can do like this, so that now whenever the element is available for us in the effect, we can able to get it. So now if I try to parent check does not exist. Okay, fine. So are we using the parent check here in our app component? Yeah, here we are using it. Let's try to remove this one. I am trying to remove this one. Yeah. So now let's try to see the output for this one. So here we are able to see the output, and if you go to the inspect element in the console, see you are able to get an element ref and also the computed signal. So how we are able to get it? So previously when you are using the traditional, so we need to use the ng after view unit only, we are able to find this one. But here in the constructor, by using the effect, I can able to find it. Here effect is used to reactively log the query results whenever they change. So now querying multiple elements. So if you want to query the multiple elements means, then we will be using the view children. So for example, let's say that in our app component only, let's say I am having two elements. Let's say it's the same thing, we are having two elements. So now I want to access this one means, then what I need to do here in our app component.ts file, here we need to use the view, sorry, not for this one. So we know that these are multiple. So here we need to check the view children. That's it. So now we can get the array of, so here you will be able to see, so signal array of the elements, you will be able to get it. So this is how you can get it. So query options. So we will be having some query options. Both view child and view children support the options to customize the behavior of the query. One key option is read, which allow you to specify what to inject from the match nodes. For example, let's say that, so here this is our view child. We are getting a component. If you try to see the output for this one, so here we are able to see it is getting array of element refs, and this one is a computed signal component. So that means it is an instance of that component. But if you want to read this one as an element ref means, then what can I do it is, so here I can pass an extra option. So it will take only one option, that is nothing but read option, and here I can provide something like element ref. That's it. So that means, so we are trying to read this component as a element ref. Now if you try to see here, so we are getting this one as an element ref as a native element. Even though the query is targeting the component, using the read element ref option ensures that the query returns an element ref instead of the component instance. That is the thing. So using Angular signal queries in Angular reactive system. So see, since signal queries return signal objects, you can seamlessly compose them with other signals also. Use them inside computed signals or react to changes. Whatever the thing you want, you can do it. For example, let's say that you are having an element size means, so let's say that here I will try to take the view child only. Okay, single one only I will take it. So right now we are having only single one. Yeah. So now in our app component, so we are having two things, right? So if you want to capture the element size means, so you can have an element size also, element size, so which is a computed property. So here I can have a computed. So these are all the things I can, sorry, These are all the things I can use it when we are trying to use the signals thing. So computed of constant el is equal to, so we can get this dot dvel is there. So when dvel is available, sorry, this dot dvel is available, whenever this one is available, then what I want to do, so I want to get the native element, okay. So that's it. So now here you will be able to get it. Does not exist on type. Okay, so here we have what is it is telling to tell is, so whenever this dvl is there is there means then I can get this dot div el dot native element, or otherwise I can get an empty. So like this also you can use it. So div el, so why it is telling it's an element ref only, right? Signal of unknown. Okay. So here you need to tell it is of type element ref. Okay, so then you will be able to get this one. So element ref possibly object possibly undefined. So I have written this condition, right? Use this one, or otherwise I will try to remove this entire thing, and here you will get an element. Okay, that's it. So now we can use this div element dot native element, and if you want to get the element height means, so you can return element is there means then element dot offset width, I can send the offset width into, so just I am trying to do element dot offset height. Okay, so or otherwise if it is not available means I will try to send the 0 only. So this like this you can send it, and in in constructor or something like that what I can do, so I can do the this dot ul, and here I can use the element size. Okay, I can get the element size. So that means nothing but the paragraph element size I can able to get it. So here I have used the div element, but actually it one is in paragraph element. Now here you are able to get the 14288. So into I have did it, right? So that is the reason I am able to get it. So this is how we can able to use the signal queries and all those things. So computed we can use it to calculate the size of the queried paragraph element. Effect listens to the changes in both the component and element size signal, that effect thing. So comparing this signal based queries to the input based, that one is decorator based queries, is traditional Angular queries use decorators like @viewchild, @viewchildren, that one. The signal based approach, so here I will try to write it so that you can able to understand very easily. So the difference between these, traditional Angular queries use decorators like viewchild and viewchildren. The signal based approach replaces decorators with functional API calls like viewchild and viewchildren, returning reactive signal objects. What is the key differences between those two is, so one is the reactive. Okay, signal based queries automatically update whenever the view changes, while decorator based queries require manual handling to react to changes. Functional API, signal based queries use functions instead of decorators, which provides a more functional programming style. So that is about the view child and also view children, how we can use it in the signal based queries. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will try to learn about the content queries in the Angular. So content queries means normal, not traditional content queries. This is signal based content queries. Normally the content queries in Angular allow a component to access child elements that are projected into its content from a parent component, rather than those defined directly in its own template. These queries are useful when you want to interact with or manipulate the projected content in a dynamic way. So let's break down the key points and provide a step-by-step example. Let's try to see it. First one is the content child. It is for a single query. The content child function is used to retrieve a single element for directive from the projected content. So normally you can query for element ref or otherwise a component or a directive by passing a reference to that class. So let's try to have this one. For example, let's say that I am having a widget component here. So I am having a widget component, and in our app component, so here in our app component.html file, so this is our computed signal, let's assume. Okay, and in this one I will provide something like h1. Okay, this is the header or anything I will try to provide, and in this one also I will try to provide a app-widget. Okay, so that's it. So now if you try to see in our app.component.ts file, so I am implementing the widget thing. So here in this app computed signal I am sending the two things. One is a more normal element and in another one is a component. Let's try to go to the computed. Okay, computed signal component.ts file. So here I will be removing this entire code and let's go to the computed.signal.html file, and here I will be having a div, and in this one I will show the ng content. So this is our ng content. Fine, that's it. So now let's try to see the output for this one. So if you try to see the output for this one, so you will be able to see this is the header and widget. So we are able to see both the things. Now if you want to access the header element and also a widget, which is a content projected into the element. So if you want to access this one, means in our computer signal component.ts file. So here you need to access the first one is the header element. So if you want to access the header element, then we will be using the content child here. Content child of element ref. So we know that it is an element ref. So you need to provide it as an element ref, and here you need to provide the h1. That's it. So now we are able to get the element, and the another one is header. So here another one is the widget. So here I can use the widget is equal to content child of widget component, right? So widget component, that's it. So now both of the things, if you want to access this one in our constructor, let's go to the constructor, and in this one we will be having an effect. Okay, and in this effect I will try to console.log the header element, and also I will try to console.log of widget. That's it. So now here we need to provide it something like this one. So hopefully everything will work fine. So this is our effect thing. Now if you try to see the output for this one, so let's try to see the output for this one. So if you go to the console and if you try to check it here, so okay, we need to add it something like this one. I forgot to add it, this one. Okay, now if I try to see the output for this one, so here we are able to see a widget component. Okay, and also I am able to see element of computer signal. Why this one is coming computer signal? Widget, we are able to get it as a widget component, we are able to get it, and header element, content element ref of header element. So here we are getting this one as undefined and 0 element ref. So we are getting because of the component.html, and here in this one, okay, so we have mentioned it in the view child, right? So we will try to remove this one all. Okay, so now if you try to see the output for this one, so now here we are able to see the widget component, and also we are getting it as an undefined. So let's go to the app component.html file. So here I will try to provide the hash h1. Okay, so we have forgot to mention this hash h1. So now if I try to go to the computer signal.h1 file, so okay, so let's see whether we can able to get the output or not. See here we are able to get the element ref and also the widget component. So normally what you will try to do, so this one instead of mentioning as an effect or something like that, so in order to get this one, ng after content init, we will be using this one, ng after content init, ng after content init. So this is the thing which we will be using normally. So but we are using the signal based content query, so we can able to get this one immediately. So this is about the content chain. If you want to get the multiple queries means, so then what you need to do, so here you need to change it to content children. So if you get this one as a content children, so let's import this content children, then you will be, why this one is getting error, content children, I'm using the same thing, yeah. So content children, now what I will try to do, so here you will be getting instead of that one as an element of element ref. So you can loop over each one for each loop or something like that, and you can get each element. So this is one way which you can get about the content children. So now the query options. So you will be having some query options inside this one. So normally if you try to see, so if you try to see the normal thing, so if you, I will try to provide a div element here. So let's try to see it. Okay, let's try to see this one. So now if I try to, so here you will be able to see that we are getting it as an empty element. Why? Because so normally the content children and content thing, so normally it will get the direct element only, direct children only it will try to get the element. So if you are having a direct, if you are not having a direct children, so it will not able to get it. So the content child and content children have several options. One is the descendant. By default queries only retrieve the direct children only. So here if you try to use this content children or anything, it will try to retrieve only the direct children only. So right now we are having only, let's try to make it content child. So direct children it will try to take it. So if you make it, if you have an option descendants to true is passed, the query will include all the descendant elements but not the components. So here you can use something like what I can do is descendants to true. Now you will be able to get the value. So here you will be able to see. So now you will be able to get the element ref also, but not the components. Components you can get it automatically, it's not a problem. And now another one is the read option. So for example, let's say that, let's try to see that one also. So here let's say that I am having a div option here. Let's see whether we can able to get it or not. Let's try to check for me also. I too am having doubt that one. So yes, we are able to widget component, we are able to get it without providing the descent thing. For only the elements, if you want to get it, means then you need to provide the descendants to true. Then only you can able to get the descendant elements, not the direct children. So now by default it will check only the direct children only. So the another option which I want to tell you is the read option. So your people already know about this read option. So if you want to get this element as an element means, so you can provide it as an element ref. So you need to provide it as an element ref. Then you can able to get this widget component also as an element ref only. So these are the two options which are available in the content child. So descendants to true means allows content children to find all the h1 elements which I have in, even those inside of a div also. Without descendants true means it could match only the direct children of that component. So that's it about this concept. So in summary, what I want to tell is content child is used for querying a single element or component in the content projection. Content children is used for querying the multiple elements or components. Both queries means I want to say is content child and also the content children. Both options will take both queries. This will take an option that is nothing but descendants and also the read option to modify their behavior. So this is all about the content child and also the content children about the signal queries. In the signal, this all you need to remember that I am trying to do everything in the signal only. So everything is in the development preview only. So don't think that these are the stable thing. But I am trying to explain you why, because tomorrow in Angular 19 or something like that, it may become stable. But it worthful learning the new concept. Hope you understood about this content child and content children. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will try to talk about the signal based child queries in Angular, focusing on the view child, content child, view children and also the content children with signals. Let's go step by step through the key concepts and how to use these queries with examples. So understanding the child queries in the Angular. So child queries in Angular allow you to access elements or child components from the template of your component. These queries can be used for single elements and also the multiple elements. Like single elements means view child or the content child, and multiple elements means view children or the content children. So before Angular 18, so if you try to understand, before Angular 18, we used decorators like @view child and also @content child, etc. to query child elements. With Angular 18, the new signal based queries approach allows you to access these elements via signals, making it more reactive. So how the signal based thing will work? Let's try to understand how the signal based queries work. So a signal based query returns the results as signals, allowing you to track and respond to changes more naturally. You can also query with view child for querying a single element from the view children for querying multiple elements from the view, content child for querying a single element projected into contents using the ng content, content children for querying the multiple element projected into the ng content. So these are all the 4 examples we have already seen in our previous video. So I want to tell you another important concept, that is nothing but required queries, which we haven't covered it about this one. So required queries, for example, let's say that sometimes you want to enforce that a query must always find at least one result. Example, a view child query should never be undefined. So you can use .required to make sure a query is mandatory. If no result is found means Angular will throw a runtime error. So this is one thing. And also another one which I want to explain you is the query availability timing. So when it will be available. So when Angular builds a component, there is a period where the signal query has been created, but the template has not been fully processed. During this time, the queries will return undefined for a single result query like view child, and empty array for multiple result queries like view children. So this one is already we have seen it. So query results also, you need to understand that query results are also resolved lazily, meaning Angular will only process and update the query when you explicitly read the signal. So the another one is query declarations and usage. So these are all the important concepts which you need to understand before using the signal based queries. Query declaration and usage. You can only declare signal based queries in class properties. These functions should not be called in other parts of the component, example in a constructor. Now let's walk through a complete example step by step. So I want to try to do. Let's create an Angular component. So we already have an Angular component like computer signal. So we will we in our computer signal.component.html file. So let's say that we will be having some code. So let's say I will be having a div element. Let's say that this is a required element. So required element, okay, and I am required. So I will be using I am required. That's it. So now we will be having another one. So I will be having another one div element. So I am optional. Optional means so this one will be coming as an with an ngif. Okay, fine. Let's try to add an ngif. I will add an ngif, and here show element. I will use a method that is nothing but signal value show element. So we will try to add it to this one. So here you will be having, okay, and we will be having another button. Okay, so here toggle optional element. So I will be using the toggling the optional element, and I will click on this one so that you will be able to see the toggle element. So this is the code which I will be trying to show you. And in our signal component.ts file, I will try to remove this entire code. And here what I will try to do, so let's take the required element is equal to view child. So this one we know that this is the required, so you can use the dot required, and here this is the required element. That's it. And we will be having an optional element. So you know that we have an optional element view child. So you can have it optional means optional element. That's it. And we will be having another one is nothing but show element. So we have a signal value, right? Show element. I will be having a show element, and this one is a signal of. So at the first time I will keep it as a false. So it controls whether the optional element is shown in or not. So now, okay. So here in our ng after view init. So we know that in this one all the elements will be available, right? So I will try to console.log this dot required element, okay, and I will need to have an optional element also. So here I will try to do optional element. That's it. So now if you go here and if you, okay, toggle element. So we need to have a toggle element also. So here I will try to do it. Yeah, in our thing. So we will have a toggle element method, that is nothing but toggle element, and in this one what I will try to do is, so here this dot show element dot set of not of this dot show element. That's it. Okay, let's see the output for this one. So here I will be having this code. So cannot bind ngf as it is known unknown property means, so we need to import the common module here. That's it. So hopefully now we will be able to get the output. Yeah, so fine. I am optional, I am required. So here we are able to see the output. So here we are having a signal of false show element. If not of show element, if show element is there means then only will show. So then why it is showing this one show? Okay, here I need to use like this. That's it. So now if you try to see the output for this one, so here we are not able to show it. So here explanation what I want to tell is, I will try to explain you the code which I have written. So view child dot required. So here this query is marked as required. Angular will throw an error if the element is missing, and we are having optional view child. This query is optional. It might return undefined when the element is not in the DOM. So we are using a signal show element to control whether the optional element is displayed or hidden. So now ng after init we can access both the query results. Required element is guaranteed to exist, so it locks the element. Optional element. So now if I try to show the output for this one, so here we are able to see it is an undefined. Why? Because optional element is not available. So if I try to click on this toggle thing, so we are not able to show the toggle thing. Why? So here okay, we will try to update this one. Value is equal to, I don't know, not a value. So let's try to check it like this. Maybe I'm thinking of something like this. So let's try to see the output. Yeah, so now we are able to see the toggling thing. So now we are able to see it's an undefined. So now toggling, so we add a button to toggle the visibility of the optional element. Since view child returns a signal, its value will be updated lazily based on whether the element is present in the DOM or not. Understanding the query timing and errors by marking a query as required. So now if you try to see an element, for example, if I try to keep this one as a required field, So now what will happen? Let's see. Then it will throw an error for you. So runtime error. So you will get a runtime error. Why? Because we have marked this one as an required field, but that one is an optional. So this is how we can use the required field in order to throw an error, or in order to get an undefined value. So understanding the query timing. So by making a query as required means, so query enforces the query must always return a result. If the result is not available means it will encounter a runtime error. I already shown you about this one. So this is all about the signal based view child and all those things required query. So the summary of this one which I want to explain you is, so the reactivity, the first one is why we need to use this one is, first concept is the reactivity. Query results are exposed as signals which can be used in computed or effect signals. Lazy resolution. Results are resolved on demand when you access the signals, making the process more efficient. Stricter type safety. So this is the main thing. By marking queries as required, you eliminate undefined from the type signature whenever the result is mandatory. So that's the main thing. This approach allows you to handle the query results in a more reactive and a predictable way, aligning with Angular overall signal architecture. So this is all about the querying of the things in the signal based queries, or view child and the content child. So hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. I will try to give the reply. And if you like this video, please do support me by subscribing to my channel. Thank you.